What can we do? Okay, I've started the recording. Hey, everybody, we're live and in stereo. So, welcome to the marathon session, which is for organic chemistry. And this is basically for your 2024 May June examination, which is in 5 days for some students. 4 days for some students, and because they are in Saudi or something like that, and in like 7 8 days, in a week or so time for all the other students. So we'll be covering the entire organic chemistry from scratch in this particular session. We have like 100 students, but unfortunately the participant limit could not be I could not exceed the limit for it in Zoom. I had to buy a bigger package for that, which I'm not gonna do. But this video is going to be uploaded on the YouTube channel at Carboxyl Chem, and you can always watch this video if you if you did not get the opportunity to join this class. So we want Zara in this class. Zara is late, yeah, so we already have students. Unless somebody leaves, it is what it is, right? So I'll quickly be going over all the basics of organic chemistry, and from the scratch till the most advanced questions and all of that good stuff. So just bear with me. It's going to be a long night, and yeah, wish you the best of luck. Let's see how many of you persevere through this entire 4 hour class. We'll also have breaks in between, so don't worry about it, right? Okay, G, let's start. So basically, let's talk about our organic chemistry. Organic chemistry is the study of carbon-containing compounds because carbon has the ability to make long chains and rings, right? So will you be doing all the topics? I'll be doing all the topics. Yes, Aima. So after we're done with this, we'll figure something out. Okay. So organic chemistry in the study of carbon-containing compounds, but not just carbon-containing compounds, right? We do not discuss carbon dioxide in organic chemistry. We do not discuss carbon monoxide in organic chemistry as a family, right? Why? Because carbon has this ability to catenate. What is catenate? Catenation is the ability of carbon to make long chains and rings, everybody, right? And because it can make long chains and rings, that transitions us into the different type of families of organic compounds, which is basically our alkanes, which are our alkenes, our alcohols, our carboxylic acids, our esters, and so on and so forth, right? So in our course, we have the alkanes, alkenes, alcohols, carboxylic acids, esters, and that's it, right? So these are the only families that we have to study in our course. Yes, later on, when you go into A levels, you're also going to study your families like ketones and aldehydes and so on and so forth. For now, they're not our concern, right? So let's start off with the first family, which is basically our alkanes. Now, before I teach you guys the what alkanes really are, let's look at a few examples in our day-to-day life of in our day-to-day lives for alkanes, right? So alkanes, we all have come across alkanes in our day-to-day life, although we might not know it, but we have come across alkanes, like our cooking gas, right? Cooking gas is also known as like your natural gas. So alkane, one of the most beautiful alkane, which is your methane, it's the main constituent of your natural gas. It's the main constituent of cooking gas. Yes, it's usually referred to, natural gas is usually referred to methane, which is an alkane, but that's not the case. Methane is basically a greater portion of natural gas. So we say that it's the main constituent of natural gas. And this natural gas or cooking gas is pumped into our homes, and we use it as fuels for cooking our scrumptious foods and all of that good stuff. And methane, in fact, is the smallest alkane in the entire world. Not just the smallest alkane, but it's the smallest organic compound that you guys are going to come across, right? So methane is the smallest organic compound in the entire organic chemistry. If I were to ask you what is the smallest organic compound, that's methane, which is an alkane, right? Similarly, you have other alkanes as well, like your cylinder gas is an okay, please mute yourself. Yeah, so your cylinder gas is also an alkane. You know, when we used to be back when we were in school, we used to come out of our school at we used to bunk sometimes as well, but we used to go out and on the streets, these vendors used to sell these French fries, and they used to use these cylinders, right? So that particular cylinder gas had an alkane in it, which is propane. your LPG gas, liquefied petroleum gas, in your alkanes are literally used everywhere, right? Certain heavier alkanes are used in waxes, in candles, in lubricating oil. So many examples, day-to-day examples of alkanes. But the question still remains, what are alkanes? We have studied, okay, we have alkanes all around us, but what really are alkanes, sir? Alkanes are saturated hydrocarbons. Now, the next question could be, sir, what do we mean by saturated? What do we mean by hydrocarbons? Saturated are compounds having carbon-carbon single bonds only. So I'll write it here, compounds having carbon-carbon single bonds only. So whenever carbons are going to bond with each other, they are going to bond through single bonds. And that's the reason why I'm writing only here. There is no room for error in this particular concept, because whenever carbons are going to bond, they are going to bond through single bonds. There's not going to be a double bond, not going to be a triple bond and whatnot. They're always going to be carbon-carbon single bonds only. And hydrocarbons mean that they will be such compounds having carbon and hydrogen atoms only. Hydro basically comes from hydrogen, and carbons obviously mean carbons. So they are those compounds which have a carbon, having carbon and hydrogen atoms only, which means you're not going to find any other atom. In organic chemistry, you'll realize that you find certain elements like sulfur, nitrogen, oxygen in certain compounds as well. But in alkenes in particular, they are hydrocarbons, which means that they will only contain carbon and hydrogen atoms, right? And they are saturated, which means whenever an alkane is formed, because we know that organic chemistry is the study of carbon containing compounds, and the reason for that is that carbon can make these long chains or rings called catenations. So because of carbon's ability to catenate, it can form these beautiful alkanes. But whenever carbon forms these rings or chains, they are always going to make single bonds, everybody. Chains are not in your course. Rings are not in your course. You learn that in A levels, in A2 particularly, but the chains are a part of your course. Now, these two properties or these two characteristics of alkanes are going to further help us in drawing their structures. But before we learn how to draw the structures of alkanes, we know how to name them. Now, how do we name our alkanes, or how do we name our organic compounds? There is this beautiful nomenclature, right? It's a naming convention. It's just a set of rules that helps us in naming organic compounds. So I'll add this beautiful table right here, which consists of certain prefixes. So this table right here, it is a table of prefixes, and this table of prefixes was created by, sir, जिन बच्चों ने pay किया है वो join नहीं कर सक रहे. I don't care, man. You should have been here on time. Okay, so it is this set of prefixes. What is a prefix? Which comes before the word, right? So these set of prefixes were developed by IUPAC, which is the International Union of Applied IUPAC of Physical and Applied Chemistry. So they came up with this naming convention so that it is easier to name every it is easier to name every single organic compound in the entire world. And these prefixes actually tell you the number of carbons. So if I talk about meth, meth means 1 carbon. If I talk about F means 2 carbon. Prop means 3. But means 4. Pent means 5. Like, you've studied all of this in mathematics as well. Have you not come across the shapes which is like a pentagon, right? So what is a pentagon? A pentagon is a shape with 5 sides. Pentagon. Why is it a shape with 5 sides? Because the pent literally stands for 5 and agon literally means sides. That's why pentagon is a shape with 5 sides. Octagon. Octagon, yeah, we've come across this. Oct literally means 8, agon means sides. That is why it is a shape with 8 sides. Hexagon, hex means 6, and agon means sides, so shape with 6 sides. Octopus, octopus. Why is octopus known as an octopus? Because oct literally stands for 8, right? It has 8 tentacles. So these are the prefixes which are widely used by chemists as well to name these organic compounds. Now, how will we name our alkanes? Basically, the alkanes are very easy to name. How do you name them? Basically, what happens is, just like we added pent here as the prefix, this was our prefix, right? And we are going to add agon as the suffix, because agon literally means it is a shape. We're telling, sorry, it has sides, right? So we're telling everybody that pent means 5 and agon means sides. So a shape with 5 sides. Similarly, if you want to name an alkane, you have to replace the alk bit with the number of carbons. So if I'm talking about an alkane with 1 carbon, I'm going to replace the alk with meth. If I'm talking about an alkane with 2 carbons, I'm going to replace it with eth, because eth literally stands for 2. If I'm talking about an alkane with 5 carbons, I'm going to replace this alk with pent. Now what's going to happen? I add these prefixes because I know I'm talking about an alkane with 1 carbon, with 2 carbons, with 5 carbons. And what should the suffix be? The suffix should not be agon, because agon means side, right? So the suffix should be the ane. The ane literally drops down to tell everyone that it's an alkane. So how do you name a 1 carbon alkane? Well, you replace the alk bit with the prefix, which is meth, and the ane literally drops down to tell the entire world that this particular compound is an alkane, and you could literally find that out just by looking at the ane. So all alkanes are going to end with an ane. So if I were to name certain alkanes for you guys, all the first 10 alkanes, you could say the first one is methane, the second one is eth, and the ane will drop down. The third one is prop, and the ane will drop down. It's a 3 carbon alkane. If I want to ask you to please like name a 6 carbon alkane, so if it's a 6 carbon alkane, we need to understand that 6 is going to be replaced with hex, because that's the prefix. And since it is an alkane, the A and E will drop down. Please, if you get the spellings wrong in naming alkanes, you are not going to get any marks. In organic chemistry, there is this misconception from students' perspective, okay, sir, if we name the compounds wrong, will we get the spelling mistake and this and that? Yes, there are deductions for spelling mistakes in organic chemistry. Spelling mistakes for English is not deducted. For naming compounds is deducted. So if you write hexane as HEXAANE, 0 marks, right? So you have to name it properly. And it's very easy. The alk bit is replaced with the prefix, which means the number of carbons, and the suffix will just drop down, which is the ane. So in conclusion, the name of organic tells the name of an organic compound tells you two things about the tells you two things. Number one, it tells you the family that it belongs to. Because it ends with an ane, we can safely say that it belongs to an alkane. And it also tells you the number of carbons. So because the prefix was hex, I know that it has 6 carbons. So it's an alkane with 6 carbons. Prop means 3. So it's, and because it ends with an ane, we know that it's an alkane. So we could literally say that it's an alkane with 3 carbons. So in conclusion, the name of organic compound tells us both the family and the number of carbons that are in a particular compound. Now let's talk about drawing these alkanes. I hope we've learned how to name them. If those of you who don't know, I'll just add them here. So first one, for 1 carbon alkene is methane, 2 carbon alkene is ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. Yeah, they all are going to end with an A and E. The next question is, how do you draw these beautiful creatures? They're not creatures, but how do you draw these beautiful structures? Now, Before we learn how to draw these alkanes officially, there is a prerequisite information that you all need to know. And what is that prerequisite? You all need to understand that since we're dealing with carbons, you need to know how many bonds each carbon atom is going to make. How many bonds does a carbon atom make? Well, carbon has 4 electrons in its outermost shell because it is in group 4. Group 4, because we know that it's in group 4, we automatically also know that it has 4 electrons in its outermost shell because the group number tells you the valence electrons. So since it has 4 electrons in its outermost shell, how many more electrons does carbon need to become stable? Carbon needs 4 more electrons to become stable. Therefore, carbon makes 4 bonds. The number of electrons which are needed for an atom to become stable are the number of bonds that it makes. So carbon, we need to understand, makes 4 bonds, right? This is a beautiful prerequisite of organic chemistry. You need to know this. Without this, you cannot understand organic chemistry, right? So it's a simple concept. Carbon needs 4 electrons to become stable. Therefore, it makes 4 bonds. Now, if I want to draw, let's suppose ethane. Yeah, I want to draw ethane. How am I going to draw it? See, I told you guys that alkanes are saturated hydrocarbons, right? The eth basically stands for 2 carbons, yes? And because it ends with an ane, I can say that it's an alkane. And alkanes are what, everybody? Alkanes are saturated hydrocarbons, right? So if it's eth, we know that there are going to be 2 carbons, 1 and 2. That's my carbon number 1. That's my carbon number 2, right? So by when will you be able to post this? By morning? Yes, by tomorrow, inshallah, hopefully. So we have 2 carbons. Eth stands for 2. Therefore, we have 2 carbons right here. And because it ends with an ane, we know that it's our beautiful alkanes. And alkanes are what? Saturated hydrocarbons. What do we mean by saturated, everybody? What do we mean by saturated? Saturated means that they are compounds with carbon-carbon single bonds only. So we're going to draw a single bond right here. That's number 1, everybody. And they are hydrocarbons. So hydrocarbon means that it's only going to consist of carbon and hydrogen atoms. There are only going to be carbon atoms and hydrogen atoms. We've already drawn the carbon atoms, and we know that each carbon makes a total of 4 bonds. This leftmost carbon has already made 1 bond. How many more bonds is it going to make? Obviously, it's going to make 3 more bonds. How many more bonds is this going to make? Obviously, it's going to make 3 more bonds. And what are they going to make the bonds with? They're going to make the bonds with hydrogen because they're hydrocarbons. We have already drawn the carbons. The only other atoms that are left is basically the hydrogen atoms. So that is the structure of ethane. We draw the structures based on their based on what the compound is actually, right? What the compound actually is, what alkanes is. ये पहले जमाल की वजह से था. Guys, stop fighting in the chat box. Yeah, focus here. You have a paper in a few days. Stop. Okay. Now, we draw them based on the 2 characteristics of alkenes, which are they are saturated hydrocarbons. So whenever you have an alkene, or between the carbon atoms, there are going to be single bonds, and all the other bonds are going to be with the hydrogen atoms because they are hydrocarbons. And drawings like these are called displayed formulas, right? So these are called displayed formulas, yeah, right here. Drawings like these. Yeah. In displayed formula, we show all the atoms and all the bonds. We are showing all the atoms. We're showing these, we're telling the examiner, hey, there are 2 atoms of carbon, 1, 2, 3, 4, 5, 6. There are 6 atoms of hydrogen. So I'm showing you all the atoms and I'm showing you all the bonds as well. Each short line represents a covalent bond. Remember, they are all, carbon is a non-metal, hydrogen is a non-metal. There are covalent bonds between them, right? So each short line represents a covalent bond. It's a pair of electron that is shared between carbon and hydrogen. And we are telling the examiner all the atoms that are in this molecule. So that is the reason why this is known as a displayed formula. Now let's make some structures of the first 10 alkanes. So also, for some of you, this might be a little boring because obviously it's so basic, but for some of you who have not studied organic chemistry at all, this might be really helpful. Okay, how do you draw the first 10 alkenes? Let's draw it up. Let's name it first. Methane, ethane, and then a 3-carbon alkene. 3 means prop, and because it's an alkene, it's going to end with an ane. 4 means like our bute. Because it's an alkene, it'll end with an ane. 5 means pent, because it's an alkane, it's going to end with an ane. 6 means hex, because it's an alkane, it's going to end with an ane. We're just going to draw the first 6, right? The other 4 you guys can draw it in the break time. Okay, so let's draw it. Meth means 1 carbon, so we're going to draw 1 carbon first, and it says here alkanes, it ends with an ane, which means that it's an alkanes. Alkanes are saturated hydrocarbons, which means saturated means that there are going to be single bonds between the carbon atoms. There is only 1 carbon atom, so I'm Gucci here. And hydrocarbon means that there are going to be carbon and hydrogen atoms only. I've drawn the carbon, so only the other only atoms which are left are the hydrogen atoms right here. So I'll draw them beautifully. Ethane. Eth, we've already drawn ethane. Eth means 2 carbons. Let's draw it. Because it ends with an A and E, we know that it's an alkane. Alkanes are saturated hydrocarbons. Saturated means that there's going to be a single bond between carbon and carbon atoms. And hydrocarbon means that they are going to consist of carbon and hydrogen atoms only. So I'm going to draw all the other hydrogen atoms because carbon makes 4 bonds. Yeah. Propane. Prop means 3. 1, 2, 3. Since it's saturated, it's an alkane, so we say it's a saturated and hydrocarbon, right? Alkenes are saturated hydrocarbons. Saturated means carbon-carbon single bonds only, and hydrocarbons mean that all the other bonds should be with hydrogens, right? They must contain hydrogen and carbon atoms only. Then let's talk about like butane. But means 4 because it ends with an ane. We know it's an alkanes. Alkanes are saturated and they are hydrocarbons. Now, I'll not write the H's over and over again. Please, I am not writing the H's here. You guys should write the H's. I'm just saving time. Next, let's talk about pentane, meth, eth, prop, buta, penta, right? So we have pent, and because it's an A, it ends with an ane. We know it's an alkanes. Alkanes are what? They are saturated hydrocarbons. It's so easy to draw the structures. Hexane. Hex literally means a 6. 1, 2, 3, 4, 5, 6, right? And because it ends with an ane, you know that it's an alkane. Alkanes are saturated, means carbon-carbon single bonds only, and hydrocarbon, which means all the other bonds should be with the carbon atoms. Done? So these are the displayed formula of all your alkanes. What is the displayed formula? A displayed formula is a representation or is a type of presentation in which we show all the bonds between atoms. We show all the bonds between atoms, and that's it. We show all the atoms and all the bonds between the atoms. So that's how we can easily make its structure. Now, the next question is, how do we make the structural formula? There's also something else. This is one type of presentation. This presentation is known as the displayed formula. Yeah. There's also another type of presentation which is known as the structural formula. What is a structural formula? Well, the structural formula is basically a condensed version of the displayed formula. Scientists, they got so tired of making all the atoms, all the bonds, showing all the atoms, showing all the bonds. So scientists were like, hey, let's just condense them, right? So a structural formula shows each unit in a structure and it shows no bonds, right? So we don't show, okay, hey, this is a bond, this is a bond, this is a bond. We show this as a unit, but we don't show the bonds, except if you have a carbon-carbon double bond. If you have a carbon-carbon double bond, you show it, or a triple bond, you show it. Other than that, you don't show any bonds. What do I mean by this, sir? Let me teach you, right? So if we look at ethane, how do we make the structural formula of ethane? Well, we condense it. How do you condense it? I'm going to select this carbon right here, and I'm going to check how many hydrogen it's bonded to. So this is bonded to 1 hydrogen, 1 hydrogen, 1 hydrogen. So this carbon is bonded to how many hydrogens? It's bonded to 3 hydrogens. So the number of hydrogens that this carbon is going to be bonded to is going to be written in the subscript. Subscript is the one that comes at the bottom. Superscript is the one that comes at the power, right? So we write it as the subscript. You have 1 carbon, it's bonded to 3 hydrogen. Then we treat this carbon as a single unit. So you have another carbon and it's bonded to how many hydrogens? Hydrogen number 1, 2, 3. So it's CH3, you have a carbon bonded to 3 hydrogens. That's the structural form. Next, you have, if you check this out, you have this is the carbon, it's bonded to 1 2 3 3 hydrogens. This carbon is bonded to 2 hydrogens. This carbon is bonded to 1 2 3 3 hydrogens, right? So carbon bonded to 3 hydrogens, then carbon is bonded to 2 hydrogens, then carbon is bonded to 3 hydrogens. So if you realize, we show each unit in the structure. What do I mean by each unit? We show this as a unit, this as a unit, this as a unit. We literally condense the displayed formula. We're not showing the single bonds here now, right? Similarly, if I were to show this right here, you have this carbon is basically, the leftmost carbon is bonded to 1 2 3 hydrogens. This carbon is bonded to 2 hydrogens. This carbon is bonded to 2 hydrogens. This carbon is bonded to 3 hydrogens. So I can say the first carbon was bonded to 3 hydrogens. The second carbon is 2 hydrogens. The third is 2 hydrogens. And the fourth is 3 hydrogens. Then you could do this here. You have 3 hydrogens. The first carbon is bonded to 3. The second is bonded to 2. The third is bonded to 2. The fourth is bonded to 2. And the last one is bonded to 3. That's the structural formula. We're condensing it, right? Then we have the first one is bonded to 3 carbons. The second one is bonded to 2. The third is bonded to 2. The fourth is bonded to 2. The fifth is bonded to 2. The sixth is bonded to 3. That's literally the structural. Let's look at methane. In methane, you only have 1 carbon. So this carbon is bonded to 1, 2, 3, 4. 4 hydrogens. So the carbon is bonded to 4 hydrogens. Done. Now, my question is, usually the examiner, nowadays, what the examiner does is he gives you the structural formula like so. And maybe he asks you to make the displayed formula. Students struggle here a lot. I don't know why they struggle. There's a very easy way to reverse the working. How do you go back from a display? How do you go back from a structural formula into the displayed formula? It's very easy. See, just like we were able to go from the displayed formula into the structural formula very easily by treating each carbon as a separate unit, each carbon bonded to 3 hydrogens. So we treat this as a unit, treat this as a unit, treat this as a unit. Similarly, what you could do is in reverse working, if I'm asked to go from structural formula into the displayed formula, how do I reverse this working? Well, you basically draw these. So a carbon is bonded to 3 hydrogens. Then you draw this. This carbon is bonded to 2 hydrogens. Then you draw this. This carbon is bonded to 2 hydrogens. Then you draw this. This carbon is bonded to 3 hydrogens, and then just complete the bonds. That's it. Because each carbon makes 4 bonds, right? This has only made 3, 1 bond here. This is made 2, 1 bond here. This is made 2, 1 bond here. This is made 3, 1 bond here. Yeah, that's it. Next, look at this. Look at this. Let's suppose you have CH3, CH2, 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 CH3. And I ask you, which alkane is this, right? So if I tell you that it's an alkane, you can just count the number of carbons. 1, 2, 3, 4, 5. It's pentane because 5 carbon means pent. And since you're asking it's an alkane, so it's going to be pent, and the suffix will just drop down as A-N-E. But if the examiner says, what is this particular compound? So the best way to find out which compound it is to draw it out, right? It's going to make things very easy for you. So if I draw carbon right here, it's bonded to 3 hydrogens. This carbon is bonded to 2 hydrogens. This carbon is bonded to 2 hydrogens. This carbon is bonded to 2 hydrogens. This carbon is bonded to 3 hydrogens. And you just complete the bonds. 1, 1, 1, 1, right? So this is, in fact, pentane. My question for you guys. So we're done with the structural formula and the molecular formula. That's it. So that's all you need to know. Now, kar lenge, moles bhi kar lenge. Focus on what I'm teaching right now. Now, another thing that you need to understand is I want to ask you guys certain examples, right? You have to tell me this. Janab, is this an alkane? Yes, no. Is this an alkane? Yes, no. Yes, no. Yes, no. No, no, no. Why is this not an alkane? No, sir, it's not an alkane. The reason why it's not an alkane, I can argue with this. Hey, it is an alkane. Why? Because it's carbon-carbon single bond. It's saturated. You know, I can argue with you. But you guys should argue back with me. Sir, although it is a saturated compound, although it is saturated, it is not a hydrocarbon. For a particular compound to be an alkane, it must be a saturated hydrocarbon. No, you are wrong. It's not unsaturated. It is saturated, but it's not a hydrocarbon. So it cannot be an alkene. Please note that in order for a compound to be an alkene, it must meet both the properties. Okay, let's look at something else. What is this, sir? Not a part of your course. It's aldehyde. Nobody cares. It's ethanol. Okay, let's look at this. Yeah, let's look at this. Sir, is this an alkene? Yes, no. Don't tell me what it is. I know you guys are studied organic chemistry. You might know it's an alkene, but who cares? I just want to know whether it's an alkane. Yes, no. No, sir, it's not an alkane. But sir can argue with you, okay, hey, it's a hydrocarbon. Alkanes are hydrocarbons. It is a hydrocarbon because it's only consisting of carbon and hydrogen atoms only. Yeah, only. But you guys should argue back with me, sir, although it is a hydrocarbon, it is not saturated. And not saturated basically means unsaturated. So it's not saturated, therefore it cannot be an alkane, everybody. Done. So this was one thing I wanted to test here. It's an alkene. Yes, you're right. What are alkenes? We'll study later on. Okay. So these are certain structural formulas displayed from now. There's a third type of formula, which we call the molecular formula. And please note that the definition of molecular formula is going to come in your paper this time. That's what I think, right? And if you write any other definition than the one given in the paper, you're going to get 0 marks. Please note very clearly, before you're going for your examination, open your syllabus, press Control F, and in F search define. Wherever the syllabus writes define, you have to use the exact definition, please, right? So if you talk about molecular formula, that's the third type of representation. The first presentation was displayed formula, where we showed all the bonds and all the atoms. The second formula was the structural formula, in which we just write it down. Sometimes what the examiner does is he says, write the structural formula. Then we have to write it down. Sometimes he says, draw the structural formula. What does this mean? Draw the structural formula. Draw, make this into this, draw it. So it's basically a technical way of asking you to draw the displayed formula. So instead of making it easier for you guys by telling you draw the displayed formula, he says, draw the structural formula. He's asking you to draw this out, show all the bonds, right? But if he says write it down, then you just write it down. Okay, what is the molecular formula? Molecular formula, as your syllabus defines it, is the number and type of different atoms in one molecule. Different atoms in one molecule. What does this mean? In simpler words, what this means is that you take all the elements in a particular molecule and you write them down. So if you look at our ethane, we will take, ethane only has 2 elements, right? It has carbon and it has hydrogen. And then you just sum up all the elements, all the atoms of each element present and write it as a subscript. So example is that you have carbon and hydrogen in ethane because obviously they're hydrocarbons. How many atoms of carbon do you have? 2, you write it as the subscript. How many atoms of hydrogen do you have? 6, you write it as the subscript. That is why it's saying it is the number and type. Type means it's the element, right? The different type of atoms means that there's going to be different elements. So you write all the different elements and then you write their number in the subscript. So it's C2H6. Then let's sum all of this up, right? Let's sum all of this up. Please help me out. So you have 3 carbons. You write the elements, which is carbon and hydrogen only. Obviously, they're hydrocarbons. How many atoms of carbon do you have? 3. How many atoms of hydrogen do you have? Count it up, please. 3, 5, 6, 7, 8. 8. How many carbons do you have here? 4. Please count the hydrogens for me. It's 10. How many carbons do you have? You have 5 carbons. Please count the hydrogens for me. It's 2, 4, 6, 8, 12. Yes, 12. Yeah. How many carbons do you have here? You have 6 carbons. And can you count the hydrogens for me? You have 14 hydrogens. I'm very fast at counting. Yeah. And if you check methane out, methane has like 1 carbon. And how many hydrogens does it have? It has 4 hydrogens. And note that the structural formula for methane is the same as its molecular formula. So sometimes in MCQs they're tested. The structural formula can never be the same as the molecular formula. That's wrong. Yeah, methane is the best example. For methane, the structural formula is CH4 as well as the molecular formula is CH4 because we have 1 carbon. So, and what we do in the molecular formula in our course is when we write the molecular formula down, what we tend to do for all the other families is we're going to learn a family of alcohols. We're going to learn a family of carboxylic acids. In alcohols, there is this group of atoms, which is the OH atoms. In carboxylic acid, you have the group of atoms where you have the COOH atoms. We show them separately in alcohols and carboxylic acid. When we come there, I'm going to tell you what I mean by this, right? And the molecular formula, why do we need to know about the molecular formula? Yes, you're right, Saima. Why do you need to know about the molecular formula? Because molecular formula is more useful useful than the empirical formula. Empirical formula kya tha? You've studied this in moles. Empirical formula is the simplest whole number ratio of the different atoms or ions in a compound. You need to know this. You must have studied this in moles and stoichiometry. You simplify them, right? For example, this is C4H10. This can further be simplified by dividing this by 2. So you're going to get C2H5. So if I say what is the empirical formula of butane, it's going to be C2H5. But the molecular formula is C4H10. Molecular formula is more useful. Why is it more useful? Because it gives you the actual information about the molecule. It tells you the reality of the molecule. The reality is that it has 4 carbons and 10 hydrogens. For empirical formula, it's just the simplest ratio. It's not the reality. It does not mean that butane has 2 carbons and 5 hydrogens. No, it's just giving you a ratio between the carbons and the hydrogens. So the molecular formula is more important. Now, there's the 4th type of representation. Kitna ganna name hai. Altaf, chill, man. There's this 4th type of representation, which is called the general formula. So up until this point, we've done the displayed formula, the structural formula, the molecular formula. Now the last representation is the general formula. And then there's something known as the skeletal formula. You learn this in A levels, right? So general formula. What is a general formula? Basically, if you write the molecular formula for all the alkanes, so number 1 is CH4, number for ethane, if I count this up, it's C2H6. For propane, it's C3H8. For butane, it's C4H10. I've counted it, right? C5H12. We literally count that up. Now, why did we need to make this general formula? What do we mean by general formula? Basically, the general formula is literally the molecular formula. The general formula is literally the molecular formula, but only in terms of N. What do we mean in terms of N? What is N? Where N is the number of carbons. Number of carbons. What do we mean by this? Well, pretty easy. This is my molecular formula. If you look at ethane, how many carbons do you have? You have 2 carbons in ethane, and look at the hydrogens. Hydrogens are twice the number of carbons plus 2, right? Jitne carbons hai, hydrogens are twice the number of that. So if you have 2 carbons, hydrogens are twice the number of that, which is 4 plus 2. If you have 3 carbons, hydrogens are twice the number of that plus 2. If you have 4 carbons, hydrogens are twice the number of that, 8 plus 2. 5 carbons, hydrogens are twice the number of that plus 2, so 12, right? So similarly, we can say that jitne carbons hai, where N is the number of carbons, so the general formula is derived from the molecular formula. Jitne carbons hai, hydrogens are going to be twice the number of that plus 2, and that is the general formula which will work for every single alkane. That is the general formula. Why did we feel the need of coming up with a general formula? Because for scientists it was very difficult to write the molecular formulas, because Sir Suleiman taught the scientists that, hey, you can draw the structural, or you can draw the displayed formula from the definition of alkanes because they're saturated hydrocarbons, and for molecular formula just write the elements and just sum all their atoms. So scientists, what they did was they faced a problem. They faced a situation. There was this alkane with 50 carbons. Right? There was this alkane with 50 carbons. Now, scientists came up to me and they told me, hey, Sir Suleiman, you said if it's an alkane with 50 carbons, if I want to write the molecular formula, I first have to make the displayed formula. I have to make 50 carbons and show single bonds between them, complete all the other bonds with hydrogens, and then count all the carbons, count all the hydrogens, and that will give me the molecular formula. It's such a headache. So I said, hey, don't worry, we can generalize things. Well, for alkenes, whenever you have a certain number of carbons, hydrogens are going to be twice the number of that plus 2. That's what the general trend is telling me. So if you have an alkane with 50 carbons, what is its molecular formula going to be? Well, because it has 50 carbons, hydrogens are twice the number of that, which is 2 times 50 plus 2. So that gives me C50 H52, H102. All right. And this is actually the favorite question of the examiner nowadays. The examiner says, yes, mere se pucha tha. Bilkul mere se pucha. I'm lying. These are just false and fabricated stories to make a connectivity in your brain, mind, busa. Okay. So this is a very favorite question of the examiner. What does the examiner do? The examiner says C20H42 Is this an alkane? Yes, no. Is this an alkane? Yes, no. Use your knowledge of general formula. Yes, it is an alkane. It comes for 2 marks. Yes, it is an alkane. Why? Because it fits the general formula of alkanes. Please, we know it's an alkene, but we tend to not be able to write English for it, right? So it fits the general formula of alkenes, that is CnH2n plus 2, and you write it down, C20H2n 2 times 20 plus 2 equals C20H42. Very favorite question of the examiner. Very favorite question. Next, he is going to tell you, hey, you have C20H40. Is this an alkane? Yes, no. No, it's not an alkane. Why? Because it does not fit the general formula. We tend to not be able to write the English. That's why I'm writing the English for you. It does not fit the general formula of alkenes, which is, that is CnH2n plus 2, right? So you tell the examiner all of this good stuff. Sir, आपने आपको 2 पे करा दिया, please. What? Okay. And sometimes what the examiner does is he gives you a compound and he goes like, these are the only 3-4 things the examiner does, right? He gives you a compound C30 and he says 860. Is this an alkane? Yes, no. No, it's not an alkane because it does not fit the general formula. Then he says, write the alkane for 30 carbons. So how do we write the alkane for 30 carbons? Well, for it to be an alkane, if it were a 30 carbon alkane, so the hydrogens should be twice the number of that, which is 60 plus 2. So that is C30H62. Done? So that is the general formula for the alkanes. Next, we also need to, so what we've learned up until this point, we've learned how to make the displayed formulas. We've learned how to make the structural formulas. We've learned how to make how to write the molecular formula or how to write the structural formula. And we've learned the concept of general formula. And before this, we learned what alkanes were. We learned how to name them. And we learned how to draw their structures, which is essentially here. And we know what are alkanes? They are saturated hydrocarbons. That's it. That's what we've done up until now. Now, you also need to know that there are certain trends in physical property. Trends in physical properties of each family. What do we mean by physical properties of each family? Well, there are certain properties which we call the physical properties, not the chemical ones, right? In a chemical property, there must be a chemical change. There is no chemical change. You just need to know a certain trend in physical properties. Which physical properties do we need to know about? Very easy. Basically, if you write down the family of alkanes, and one more thing, I'm just going to teach this once. This trend is going to apply to every single family. If you write the alkanes, the family of alkanes, now we can easily write the formulas, right? Instead of drawing the displayed structure and then counting the carbons and hydrogens in it and then writing it as the molecular formula, we can easily write the molecular formula because we know a simple fact that the number of hydrogens will always be twice the number of carbon plus 2. So 2 times 2 is 4 plus 2 is 6. C3H8, C4H10, C5H12. C6H14, yeah. So if I draw the number of draw certain families of alkanes, certain compounds in the alkane family, you'll notice as the number of carbon increases, what happens to the size of the molecule? Sayyid Khadija is saying, I can't see the screen. Sir, this would only apply to alkanes. No, goat. It would apply to every single family. This trend in physical properties apply to every single family. Why? Because as the number of carbons increases, what will happen to the size of the molecule? That's our first physical property. It's very easy. What will happen to the size? The size of the molecule will increase. Sir, how do you know that the size of the molecule will increase? Oh, you dumbo jumbo, look at this. When we were drawing these structures, what is happening to the signs? This is taking this much space. This is taking another space. This is huge. This is huger. This is larger, right? So as the number of carbons increases, the size of the molecules increase. And because the size of the molecule increases, everybody, you need to understand this. It's just for your common knowledge, right? It's to make the rote learning of physical properties easier, right? Because if you know the concept behind it, things are going to be very easy. So as the number of carbons increases, the size of the molecules increase. And because the size of the molecules increases, the intermolecular forces of attraction between molecules also increases, right? And if the intermolecular forces of attraction between molecules increases, there is a change of state from a gaseous state to a more solid state, right? Because the size of the molecules is increasing, obviously the intermolecular forces of attraction would also increase, because now you have more atoms. So more molecules, now you have more atoms, they are larger atoms, so there will be greater intermolecular force of attraction. And if there are greater intermolecular force of attraction, what should happen to the state as the number of carbons increases? Well, if the intermolecular force of attraction are increases, the state should change from a more gaseous state to a solid state. So we say, okay, what is happening is that there is a change of state from a more gaseous state to a solid state. Do we need to know the reasoning for it? No, you don't. I'm telling you the reasoning to make things easier. And now everything is going to be very simple. Everything will fall into place. You just need to know what is happening as the number of carbons increases. Now tell me, what is going to happen to the density? Very easy. Do gases have a greater density or do solids have a greater density? Please, 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 quick, quick, quick. Solids, obviously solids have a greater density, right? So we're going to say the density also increase. Now things are very easy because we understood as the size increases, the state is going to change from a more gaseous state to a more solid state because there is now increased intermolecular forces of attraction. So now we know all the other properties. Very easy. Density is increasing. What will happen to like the mass? What happens to the mass? Well, mass is obviously increasing. CH4 has a mass of 16. You can calculate the mass here by looking at the periodic table. So the mass is also increasing. So easy, yeah? And this will remain the same for every single family, because in every single family, as the number of carbon increasing, the size will increase, the state will change, and this will happen. Okay, what will happen to like we've discussed the size, state, density, mass. What will happen to like the flammability? Flammability. Well, what will happen to flammability? Now, some of you might confuse flammability with boiling points. Remember, guys, flammability is different from boiling points. Flammability is how easily it can catch fire. Can gases catch fire easily or can solids catch fire easily? Very logical. If solids were to catch fire easily, then the gas that would come to your home would not be methane gas. It would be some larger, longer chain alkane gas, some longer chain alkane, which was a solid. So आपके घर सुबह सवेरे solid delivery होती. No, gases are more flammable. Perfumes are more flammable. Gases, we all know that, the common fact. Why are gases more flammable? Because they have these weak intermolecular forces of attraction. They have the weakest intermolecular force of attraction between them, and they move randomly at high speeds. Because they have high speeds, they can easily catch flame and all of that good stuff. But the concept of why they are flammable is not in your course. You need to understand that they are flammable, and just from logical derivation, right? Because gases are more flammable than solids. Why? If they were not flammable, then in your houses you would actually get solids delivered to you for cooking. But that's not the case. You get gases, right? So what will happen to the flammability? The flammability decreases as the number of carbons increase. Done? Next, everybody, what will happen to like the boiling point? Well, it's much difficult to boil a solid compared to not difficult. Difficult, that's flammability. But what should happen to the boiling point? Well, as the number of carbons increases, the size of the molecules increases, due to which the intermolecular forces of attraction between these molecules increases. And if the intermolecular force of attraction increases between the molecules, more energy is required to break their bonds and boil it. So what should happen to the boiling point? The boiling point should also increase as the number of carbons increase. Do we need to know this reasoning? No. But if you learn it conceptually, things are going to be very easy for you. Next, volatility. What happens to volatility? What is volatility? Volatility is the tendency of a substance to evaporate at normal temperatures. And I'll give you the best example, and to escape into the air, right? I'll give you the best example. Have you ever been to a petrol pump At a petrol pump, you'll be able to smell these beautiful petrol molecules. Some people are also addicted to that, right? Why can you smell them? Because petrol is highly volatile, right? When I visited Kenya, there were certain people who used to do samad bond ka nasha. So they used to be addicted to samad bond because samad bond is also highly volatile. The particles can easily escape into the air and evaporate into the air at normal temperatures. So volatility is how easily particles can escape into the air or how easily they can evaporate at normal temperature. Janab, what will happen to the volatility? Gas is already in the air. Gas has already escaped into the air. And if you go down and down and down, you can go from a gas to a liquid to a solid. So gas is already in the air. The concept of volatility does not even apply on gases because they're the most volatile. They're already escaped into the air. But if you compare a liquid to a solid, which one is more volatile? Well, obviously liquid particles, they have weaker intermolecular force of attraction compared to solids. So they can easily escape into the air compared to solids. They are tightly packed together. So what should happen to the volatility? The volatility decreases. The ability to escape into the air decreases as the number of carbons increases. Sir, petrol is so expensive, guilty feel hota hai smelling it. Sir, why it looks like sir is giving out a speech? I'm not giving out a speech, Arsh. Hey, chill. Okay, what happens to viscosity? What do we mean by viscosity? Viscosity basically means stickiness. It means thickness. And in more scientific way, it means resistance to flow. Which substance will be more resistant to flow? A liquid or a solid? That's my question. A liquid is more resistant to flow or a solid? Obviously, a solid is more resistant to flow. It's more thick, it's more sticky. It has stronger intermolecular forces of attraction. All the reasonings are related to the intermolecular force of attraction. So it has strongest intermolecular force of attraction. It's going to be more thick, it's going to be more sticky, it's going to be more resistant to flow. I'll give you another example. If you compare two liquids, even honey and water, which one is more viscous? Sir, spelling galat hai. Viscosity. I think it's correct, yeah? Okay. Honey is more viscous than water because honey is more thick. Thickness means viscous. Thickness means stickiness. Thickness means resistant to flow. So, sir, out of honey and water, I think cocaine is more viscous. Great, man. Here, students are fighting for their lives to score full marks in organic chemistry, and this is what is happening. Sorry. Resistance, RE. Okay. Chill. I'm a chemistry teacher, not an English teacher. They don't deduct mark here. So it's the resistance. Yeah, now it's fine. Sorry. Thank you. I thought you were talking about viscosity. Okay, so that's that. So you need to know what happens to the viscosity. The viscosity increases as the number of carbons increases. Why? Because obviously the stickiness, the thickness increasing. Chemical teacher bhi kyun hai? That's it. That's all there was to alkanes. Now let's look at certain chemical reactions of alkanes. Chemical reactions. Janab, alkanes, they are generally unreactive. They're generally unreactive. Now, why are they generally unreactive? That is not a part of your course. Why are alkanes? If the examiner says, why are alkanes generally unreactive? Because they are saturated. That's it. That's the answer you need to give. Because they are saturated. Now, I'll tell you the reason. The reason is that alkanes have carbon-carbon single bonds. And you need to understand that carbon-carbon single bond is more stable than the carbon-carbon double bond, which is more stable than the carbon-carbon triple bond. And because alkanes are already single bonds, they are therefore quite unreactive because they're already stable. If something is stable, why would it want to react? I always give this example of Bill Gates, right? If Bill Gates is financially stable, why would he fight over 1 rupee? He wouldn't fight over 1 rupee, although what he would rather do is give like 1 billion rupees. No, he wouldn't give 1 billion rupees, but he's stable. So anything which is stable is generally quite unreactive. So if I say, why are alkanes generally unreactive? Because they are saturated, having the carbon-carbon single bond. That's it. That's all you have to write. You can ask me, sir, what is there in this carbon-carbon single bond that makes it more stable than the double bond? I'll just give you a quick reasoning to that. Well, one of the reasoning is that single bond means a pair of electrons is shared. Double bond means that 2 pairs of electrons are shared. If you don't get this, leave it. Triple bond means that 3 pairs of electrons are shared. Now, obviously, a single bond is more stable than a double bond, which is more stable than a triple bond, because here, when the electrons are being shared, there's going to be minimum repulsion. Electrons are negative, right? And like charges, they repel. We studied this, like charges repel. So since they are going to repel each other, the repulsion is going to be minimum here, it's going to be greater here, and it's going to be the maximum here. So this will want to react in order to convert into like a single bond. This will want to react in order to convert into a single bond. But since alkanes are already saturated, they're carbon-carbon single bonds, they they are quite unreactive, right? And this reasoning is not in your course. You just need to know alkanes are quite unreactive. Now, that is the reason why they only undergo a substitution reaction and a combustion reaction. Combustion reaction and a substitution reaction. And we also study another reaction, which is basically cracking. These are the 3 reactions in your course. Cracking was previously known as pyrolysis. If you are solving previous year's questions, you can also write pyrolysis. You will find in marking scheme at some point they've also written pyrolysis. But now you will never refer to it as pyrolysis, although it's correct, but your syllabus says just refer to it as cracking, right? Now, let's first discuss the substitution. Acha, combustion pe aate hain, but let's first it's pyrolysis, please. Altaf, chill, man. Chill. Okay. So let's first discuss the substitution reaction. Substitution reaction. What is a substitution reaction? Basically, what happens is a substitution reaction is a reaction in which one atom or a group of atoms is replaced by another atom or a group of substitute. An atom substitutes another atom. An atom replaces another atom, right? Scientists, what they wanted to do was they wanted to take these alkanes and they wanted to react with halogens. Right? They were like, no, man, alkanes, you are generally unreactive. I'm going to take you and I'm going to make sure that you react with halogens. What are halogens? Halogens are group 7 diatomic molecules like chlorine, bromine, iodine, and fluorine. But we only discuss chlorine, bromine, and iodine, right? So which metal is used for preparation of granite? Chill, peeps, chill. Okay. Okay, so after this, I'll start ignoring the chat. Okay, so those of you who have actual questions, just raise your hand and then I'll look at the chat. Because why with halogens? Well, they wanted to find out some things, right? What did they want to find out? You learn that in A levels. But they wanted to react it with halogens. All of this is fabricated stories. I just want to make sure to create connectivity in your brain. So they wanted to react it with halogens, but when they added a halogen to alkanes, sir, no reaction took place. They were like, hey, why is no reaction taking place? Well, the reason, you dumbo, that no reaction is taking place is because alkenes are generally unreactive. Alkenes are generally unreactive. They are stable. They have carbon-carbon single bond. They are unreactive. Then scientist said, nahi beta, maine to ye karna hai. Zoom user, wait. Scientist said, maine to ye karna hai. I have to react it with it. So they say, hey, provide it with something that will actually provided with the activation energy to react together. We know that in order for a reaction to take place, there must be the activation energy, which is the minimum energy to undergo successful collisions and form products. So scientists, once again, they took certain alkanes, and I'll give you the chance to speak, Zoom user. Just give me a few more minutes so I can finish the chapter of alkanes, and then we'll take your questions. Okay. So they took alkanes and they reacted with halogens, but now they were, a little more educated. They said, let's provide it with something that will give it the activation energy. It will give it the EA. And they said, hey, the best thing is UV light, which is ultraviolet light. So they noticed when they performed this experiment in ultraviolet light, the reaction took place. So what was the ultraviolet light doing? The ultraviolet light provided this reaction with the activation energy. What do we mean by activation energy? The minimum energy that reactant particles need to undergo successful collisions. You must have studied this in the previous chapters, right? Collisions, done. Afnan, hold up, man, hold up. Let me just finish this chapter, please. Okay, so that's the activation energy. And because it required the UV light, what are the products? Chill, man, I haven't finished this chapter. Once I finish it, then you'll find out the products. So because it required the UV light, it also indicated that this reaction is a photochemical reaction. So the substitution of alkanes is a photochemical reaction. What do you mean by photochemical? Photo literally means light. So a chemical reaction that requires light is a photochemical reaction. Sir, आपका Instagram नहीं मिल रहा? It's Sully_Khan. Please don't follow me, yeah? I'll write it, but don't follow me. Okay. So they noticed that when they were providing the UV light, this reaction can also be very explosive in the UV light, right? UV light basically means sunlight, but we don't write sunlight. We write ultraviolet light, right? Because in labs, we can also provide the ultraviolet light. There's no sunlight, but you can provide ultraviolet light. Now, they noticed that this reaction will not occur in the dark because it is a photochemical reaction. It requires UV light. And the UV light, what does it do? It provides it the activation energy. So what happens? The alkanes react with halogen. Let's take an example. Let's take an alkane, which is my methane. Yeah. And let's take a halogen, which is like your chlorine. Chlorine is Cl single bonded to Cl because it's in group 7. It has 7 electrons in its outermost shell. It needs 1 electron to become stable. Therefore, it makes 1 bond. That's the structure of methane. And that's the structure of chlorine. Now, what's going to happen? Scientists provided this with UV light. So what they noticed was that this was actually a substitution reaction. What is a substitution reaction? A reaction in which one atom replaces the other atom, in which one atom or a group of atoms is replaced by the other atom. So what happened was once they provided this with UV light, the chlorine went like, hey, hydrogen, I don't like you, move away. Although this is a fabricated story, there is no such conversation between chlorine and hydrogen. So please don't ask me how do they talk, yeah? But this chlorine went like, hey, hydrogen, I don't like you. I'm gonna substitute you. I'm gonna replace you. Go away. I like my carbon more, right? So what happened was, jealous people. So what happened was you formed a product that looked something like this. You had hydrogens, but this right hydrogens was replaced by a chlorine atom. This hydrogen was substituted or replaced by the chlorine atom. Now this hydrogen was very lonely. He said, hey, chlorine, if you are going to substitute me, where am I going to go? Where am I going to go if you're going to substitute me? This chlorine atom said, hey, don't worry. I have another chlorine atom waiting for you. So I'm going to leave my partner. I'm going to substitute you right here, and you can go and bond with this chlorine atom. I'm going to substitute you. You can be happy as well. So this chlorine substitutes the hydrogen atom here, and this hydrogen says, hey, chlorine says, and this says, ja, ja. Ja. The carbon is telling chlorine atom to come. So, ja. Say it with yourself. Ja. Ja. Okay. So the chlorine atom substitutes this, and the hydrogen and this chlorine atom are going to make HCl. Please note that this HCl is not an acid. This HCl is hydrogen chloride. It is not an acid. There is no water involved in this. There is no aqueous HCl. These are the steamy fumes. What you observe is you get steamy fumes, right? So aja. Now, what happens is if you provide enough chlorine, and this is called monosubstitution. This is called monosubstitution. And in your course, you only have monosubstitution. Monosubstitution means single substitution. This chlorine atom substitutes this chlorine atom's joint here, right? Now, if you provide it with enough chlorine, this reaction is actually a chain reaction. Yes, it will be most probably uploaded on YouTube, right? So this reaction is a chain reaction. If you add more chlorine, more substitutions are going to take place. So if you take this product right here, HO, and you, this was the Cl, and you add more chlorine. So this chlorine is going to say, hey, hydrogen, you are still here. Idhar say ja, hydrogen ja. And this chlorine tells the hydrogen ja. So this hydrogen goes and bonds here. So what's going to happen? The hydrogen atom is going to be once again substituted. This Cl was already there. The hydrogen atom is going to be substituted by the chlorine atom, and the hydrogen atom which was substituted is going to make HCl. Yeah. Similarly, if you add more chlorine to it, so this is the resulting product. Now I'm going to add more chlorine. Yeah. So what's going to happen is this hydrogen atom is now going to be substituted right here. So you're going to get Cl. They were already present here. And this is the new Cl that is formed, and HCl gas will form. Steamy white fumes. Yeah. And similarly, there is still one more hydrogen atom. So this can further also be substituted. So Cl. Sorry, why am I writing Cl? This is H. And then you add more chlorine to it. So what's going to happen is this hydrogen is still there. So this chlorine is going to say, hey, move out, hydrogen ja, and this chlorine is going to say hydrogen a. So, and this is actually totally false. Nothing like this takes place. It's to make O levels easy. This is actually a free radical substitution reaction. You learn this in A levels. In A levels, you're going to say, hey, sir told us such a big lie. Because there is one question that students tend to ask. Students says, why cannot these two chlorine atoms, why can they not replace these two hydrogen atoms together? That's a very valid question, but you will get the answer to that in A levels. So for now, you just have to understand, because that's not how it goes. There's not ja, right? It's a proper mechanism to it. But for now, you just have to understand that at once, only one chlorine atom can substitute one hydrogen. And then this goes on and on and on and on, right? And if you add more and more hydrogen, if they ask you to write the substitution equation of methane, you're only going to write it till mono substitution. That's what your syllabus requires you to do. But you need to understand that it's a chain reaction. If you add more and more Cls, you are going to have more and more products being formed until all the hydrogens have been substituted. Once a question came in the examination, it said if you add excess chlorine to methane, how many moles of HCl are going to form? 1, 2, 3, 4. How many different products are going to form? Well, the number of hydrogens that can be substituted are the number of different products that can be formed, right? So one different product, 2, 3, 4, 4 different products can be formed. Now let's write the equations for it as well. So for the first one, you had CH4 plus Cl2. What's going to happen? CH4 plus Cl2. One hydrogen is going to be substituted by this chlorine. So you're going to get CH, one hydrogen is substituted. Now you have CH3, and this Cl is bonded here, and then you get HCl. Next, you get CH3Cl plus Cl2 gives me what? CH2Cl2, reduce a hydrogen and increase a Cl. And then you get HCl. Again, you have CH2Cl2, you add more chlorine to it, you reduce a hydrogen and increase a Cl. So CHCl3 plus HCl. And the last one, you had CHCl3 plus Cl2 gives me what? The reduce a hydrogen. So it is going to give you CCl4 plus HCl. So these are all the reaction equations, right? All the symbol equations. Number 1, number 2, number 3, number first. Yeah, so 4 equations are right here, and what you need to understand is I've just reduced a hydrogen and increased a Cl, and HCl forms. Reduce a hydrogen, increase a Cl, and how many different products are from? See, how many times is this reaction going to take place? The number of times the number of hydrogens that you have are the number of times that this reaction is going to take place, provided if you add excess chlorine to it, right? Now the question is, okay, what is this product called? What is the product that has been formed called? What are these products? Basically, these products are your halogenoalkanes. Oh my God, sir, what are you saying? They're halogenoalkanes. You can also call them haloalkanes. What are haloalkanes? Understand it. Why are they calling it alkanes now? Because obviously all the carbon bonds are single bonds, so they're calling it alkanes. And they call it haloalkanes because it's made up of alkanes, right? So that's why it's calling it alkanes. And they're calling it halo because there is a halogen atom bonded to it. So they're called haloalkanes. And the general name haloalkanes is going to help you how to name it. Why am I calling it haloalkanes? Because it's made from an alkane, so alkanes. And halo, why? Because there's a halogen atom bonded here. So what's going to be this? What's this atom going to be called? Well, which alkane is it made up of? It's made up of methane, the first one. This one, it's made up of methane. And which halogen does it have? It has the Cl halogen, and it says halo, so we're going to write chloro. That's the name, chloromethane. Break there, please. Chill. I'll give you the break in a while. Then what is this called? This is basically made from methane. So that's methane right here. And it's a haloalkane, which means it has halogen. How many halogens does it have? 1, 2. So it has 2 chloros, right? So you say it's a chloromethane. But scientist says, hey, you're calling this chloromethane, you're calling this chloromethane. Cut me some slack. Why are you calling both of them chloromethane, right? You have to differentiate between the two. Well, scientist said, okay, here you had 1 chlorine, so we just said chloromethane. Here you have 2 chlorines, so that's why we're going to add the di to it. So we're going to say it's a dichloromethane. Di means 2, right? And in maths, tri means 3. So this one will obviously be called trichloromethane. Easy. And this one is going to be called tetra Fluoro, because 4 chlorines, right? Methane. That's the names that you need to know, not more than this. That's it. These are my haloalkanes. This is a new family that has been formed from your beautiful alkanes. Yeah? And a fun fact about these is that they're all used as solvents, but their use has recently been reduced because their uses have recently been reduced because they cause health problems and so on and so forth. But who cares? They just cause health problems. Yeah. So these are your numerinos for this substitution. That was all there is to substitution reaction. Okay, if I give you another substitution, if I say you have ethane right here, and I want you to make this, to write me the equation while reacting it with, let's suppose, Br2, right? And you're providing it with UV light. You're providing it with UV light. What's going to happen? What's going to happen? I'll just write the equations for it. So it was C2H6 plus Br2, reduce a hydrogen and add a Br. So reduce a hydrogen C2H5Br, and it's going to give you HBr. And this is going to take place how many times? It's going to take place 6 times until all the hydrogens are substituted, only if you have enough bromine. Only if you have enough bromine, and obviously if you provide the UV light to it. So that was the first chemical reaction, that is Danarino, right? Let's look at the second one, combustion. What is combustion? Combustion literally means burning. I'll tell you the exact definition, but for layman, it means burning. Burning, yeah. Sir ka Greta Thunberg ka se phadda hai. So combustion is basically burning. Why do alkanes undergo a combustion reaction? Well, the reason why they undergo a combustion reaction is because they are fuels, you dumbo. Because they are fuels, they undergo a combustion reaction. What is a combustion reaction? A combustion reaction is when any fuel burns in excess oxygen to give carbon dioxide, water, and large amounts of energy. That is what we mean by a combustion reaction. Any fuel, there must be a fuel, and it must burn in excess oxygen. What does it give you? It gives me carbon dioxide, water, and large amounts of energy. And because it gives me large amounts of energy in the form of heat, usually all the time in the form of heat, that is the reason why you guys can go from Karachi to Peshawar, you guys can go from Peshawar to Afghanistan, whatever, right? Because your cars use these alkanes. Petrol is actually alkane. It's also known as gasoline. It's the octane with you guys, right? That's what petrol is. So petrol is basically an alkane. Why can you use it to make your car go from one place to another? Because it's a fuel. It burns in oxygen. It gives you carbon dioxide and water. And it also gives you large amounts of energy, due to which the car can move from one place to another. And because it's giving carbon dioxide, that's why you guys are right. Greta Thunberg says, stop using cars, stop using buses. And she's absolutely right, because carbon dioxide is a greenhouse gas. It results in global warming, blah, blah, blah. You need to know the procedure, because that question might also be tested. Okay, so I can safely say that alkanes, they are fuels. They are going to react with excess. They're going to burn in excess oxygen to give you what? Carbon dioxide and water and large amounts of energy. We do not write energy in our equation, large amounts. You should know this, because it's the energy that makes the car or the airplane move from one place to another. Let's look at an alkane. Let's look at like methane, CH4. So what is the combustion reaction of methane? Combustion is methane burns in excess oxygen to give carbon dioxide and water and large amounts of energy. Let's look at ethane, C2H6, burns in excess oxygen to give carbon dioxide and water and large amounts of energy. C3H8 burns in excess oxygen to give carbon dioxide and water and large amounts of energy. C4H10 burns in oxygen to give excess oxygen to give large amounts of energy. So do carbon particulates form as well? Chill. I'll tell you about all of these. Wait. What about incomplete? Let me finish the chapter. Then you can ask any question, right? Gives carbon dioxide and water. I'm just creating a flow in your brains. I can't be all over the place. Okay, so that's what alk is. And the equation is literally the definition. Look at this. How do you know the definition? Sir, any fuel which burns in excess oxygen to give carbon dioxide and water and large amounts of energy is combustion. That's literally the equation is the definition. Any fuel which burns in excess oxygen to give carbon dioxide and water and large amounts of energy. Great. The next question is, how do you balance them? It's very easy. You balance the carbons first, then you balance the hydrogens, and then you balance the oxygens in the end, right? So how do we balance this? Let's look at this. Let's look at the carbons. You have one carbon on the left and one on the right. They are automatically balanced. You have I swear to God, who's this host? Yeah, who took the host from me? I'll kick you out, man.
I'm not on there.
Oh, I'm not on. Please chill out. Yeah, I'll kick you out because here students are studying for their.
Oh, I didn't do anything.
Okay, it wasn't you. Whoever it was, I'll kick you out after this. Please. Yeah, let students study. We had a very huge conversation in the discussion forum. That's why I don't like free sessions, because free sessions, everybody just comes and you, because of such people, you guys actually take away from the students who are actually in need. You are easy shush, man. So you guys actually take away from the students who are actually in need, right? Stop this. Okay, let's start. Moving on. Don't disrupt my momentum, please. Thank you very much. Sir, the recording stopped. Padda incoming. No, the recording is on. Okay. So now you balance out the oxygens. You have 2 and 2, 4 oxygens on the right. So how many oxygens do you have on the left? You have 2. So 2, what should I multiply 2 with to get 4? X is equal to 2. That's the balanced equation. Next, how do you balance this? You have 2 carbons here and 1 here. So you insert the 2 because 1 को किससे multiply करूँगी 2 है, that's 2. You have how many hydrogens? You have 6 here. You only have 2 hydrogens here. So what should I multiply 2 with to get 6? X is equal to 6 over 2. That's 3. Now balance out the oxygens. You have 4 plus 3. You have 7 oxygens on the right hand side, but you only have 2 on the left. So 2 को मैं किससे multiply करूँ कि 7 है? X is equal to 7 over 2. You write 7 over 2. But your examiner, although this is a correct equation, you cannot write it in decimal points, but you can write it in fractions. Although this is correct, the examiner says, hey, remove this fraction. So if you want to remove this fraction, you multiply the entire equation with 2, right? So you get 2C2H6 plus 7O2 plus 4CO2 plus 6H2. That's why I tell my students, whenever you're balancing an equation, do it with a pencil first, because you might require to multiply this entire equation with a 2. And that is why you do it with a pencil first and then do it with a pen, especially when you're balancing. Similarly, here you have 3 on the left, you should have 3 carbons on the right, then balance the hydrogens, 4 on the left. So obviously you should have 4 on the right, 8 on the left. So you should have 8 on the right. What should I multiply 2 with to get 8? X is equal to 4. So 4 is right here. And 3 times 2 is 6. 6 plus 4, that's 10, right? So 2 को किससे multiply करो कि 10 आए? X is equal to 5. Insert the 5, yeah? And say here you have 4 carbons. So obviously here you should have 4 carbons, 10 hydrogens. So what should I multiply 2 with to get 10? X is equal to 10 over 2. That's 5. Now check the oxygens. 4 times 2 is 8. 8 plus 5, that's 13. What should I multiply 2 with to get 13? X is equal to 13 over 2. That's right here. This is balanced equation, but since the examiner does not like fractions, you should multiply this entire equation by 2. Now, one more thing you need to understand is there's a shortcut to it. There's also a general formula for it, but there's also a shortcut to it. What's the shortcut? The shortcut is, if you notice something, the number of carbons that are there in the hydrocarbons are the number of moles of carbon dioxide that are formed. If you have 2 carbons here, 2 moles of carbon dioxide formed. 1 carbon, 1 mole. 3 carbons, 3 moles. 4 carbons, 4 moles. So you can easily balance this out by saying, hey, the number of atoms of carbon here are the number of moles of carbon dioxide will form. And the number of hydrogens here, if you notice this, the number of waters that are forming are exactly half the number of that. So if you have 6 hydrogens here, half this please, you get 3. So 3 moles of water are forming. If you have 8, half this please, you get 4 moles of water forming. If you have 10, half this please, you're getting 5 moles of H2 forming. So you can easily balance the equation by using common sense. For example, I say balance C7 H16O2. Please, can you balance this? You guys should directly now write the balanced equation. This is 7, so 7 CO2 should form. This is 16, 16 divided by 2, that's 8. So 8 H2O should form, and then in the end, balance the oxygen. This will save time. So 7 times 2 is 14. 14 plus 8, that's 22. 22. So what should I multiply 2 with to get 22? X is equal to 11. That's it. Right, so that's the combustion equation. That's the combustion equation, and you need to know how to balance it and the definition of combustion. Now, there's also something known as incomplete combustion. Incomplete. Remember, guys, the first chapter is taking a lot of time because I was teaching from the bilkul basics. After this first chapter, we're going to space up because obviously now you all know the basics. I'll give you some time to absorb these basics, and then we are going to do like bam, 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 bam. And then we're also going to do questions, right? So we are here till 1 a.m. with you guys. Yeah. Okay. Now, incomplete combustion. What do we mean by incomplete combustion? Well, sometimes what happens is that the fuel is burning, but the oxygen is not in excess. The oxygen is limited. So what is incomplete combustion? Incomplete combustion is when any fuel burns in not excess oxygen, in limited oxygen, which burns in limited oxygen. That's the difference. Burns in. You received a request to record this to cloud. No request of recording. Yeah. Deny all. It'll be uploaded on YouTube. So which burns in excess. Sorry, not excess, in limited. Yeah, it burns in limited oxygen to give what? Because it burns in limited oxygen, it's going to not give you carbon dioxide, rather it's going to give you carbon monoxide and water, and not large amounts of energy, rather small amounts of energy and small amounts of energy, not large. Now, I'll give you an example. Let's suppose you have like CH4, but the oxygen is limited. Please, some students, they think that limited oxygen means write O. No, it's still O2. In the equation, oxygen exists in the form of O2. So you're going to write O2, but it is understood that it's limited. Because it's limited, therefore, no carbon dioxide should form. Carbon monoxide forms, and water forms, and small amounts of energy. Similarly, if you have C2H6 plus O2, in this case, we are assuming that all the oxygen is limited. So if all the oxygen is limited, carbon dioxide is not going to form, carbon monoxide is going to form. Carbon monoxide is base, and water is going to form, and small amounts of energy. Carbon monoxide is basically, it's even worse than carbon dioxide. Maybe worse, maybe not. For humans, maybe. Oh, no, carbon dioxide results in global warming. But it's also very, very toxic, right? It's a poisonous gas. Carbon monoxide is a poisonous gas, and it is colorless. Please know that carbon monoxide is a colorless, poisonous gas, right? And that is the reason when we were young, I always give this example, when we were young, there was this advertisement that used to play on TVs, whenever you're sleeping at night, please make sure to turn off the gas heaters or make sure that your room has enough ventilation. Why? Because at night, what used to happen is there would be gas load shedding, Pakistan, right? So the natural gas which was used in the gas heaters was methane, right? Because methane is the natural gas is mainly it is mainly comprised of your methane. So we just say natural gas is methane, although it is not methane. It has a greater portion of methane, almost 95-96%. So the natural gas, essentially methane, it used to come in your gas heaters, and it used to react with oxygen to give carbon dioxide and water and large amounts of energy to you guys in the form of heat. But what happened was at night, when if there would not be any ventilation in your room, the oxygen would start getting used up, right? So the oxygen is being used up, and there would come a point where the oxygen would become limiting, where there would come a point where the oxygen would be limited. And when the oxygen would become limited, instead of carbon dioxide, carbon monoxide would form. And carbon monoxide is a toxic gas. It burns your inner what's it called? It burns your inner organs. It is so toxic that it can also cause your red blood cells to become sickle. You've studied the concept of sickle cell anemia in biology. Maybe you have, maybe you have not. But it also causes your red blood cells to become sickle. If these are your red blood cells, the carbon monoxide makes them something like this, which reduces the amount of oxygen that is being taken to your body, and therefore carbon monoxide can cause death. So that is why these advertisements used to be played, because so many people, bichare, they used to lose their lives because of incomplete combustion. Nowadays you have air conditions, so that's fine. Now air conditions is fine. No carbon monoxide is formed in air conditions. So where will the rest of carbon atoms go? The equation is not balanced. So balance it. Balance the equation. You have 2 carbon atoms here. How many carbon monoxide should form? 2. You have 6 H's here. How many H2O should form? 3. Very easy, right? It's this. The number of atoms in the hydrocarbon are the number of moles of carbon monoxide formed. The number of hydrogens here are the number of moles of H2O formed. And then balance the oxygen. So 2 plus 3, 5. What should I multiply 2 with to get 5? X is equal to 5 over 2. So 5 over 2, and because examiner does not like fractions, you can multiply this entire equation with 2. So the concept is the same. Chill. I'm telling you, Ayan, I'm telling you, yeah? So that is what incomplete combustion is, and that's all there was to incomplete combustion. Now, you also need to realize is that there are two types of incomplete combustion. One is where the oxygen is limited. But the other type of incomplete combustion is where the oxygen is in excess, but still incomplete combustion takes place. Why, sir? The reason for that is sometimes what happens is the fuel that you are using has a very long chain. This fuel has a very long chain, right? It's a huge chain of carbons bonded together. It's a long chain of hydrocarbons. And because this is such a long chain, although the oxygen is in excess, this bichara oxygen that is coming from the air cannot come into contact with all the carbons, although it's in excess. But the chain is so large that the oxygen cannot come into contact with all the carbons. Then what happens? Well, incomplete combustion takes place. This is the second type of incomplete combustion. When this incomplete combustion takes place, you get soot. Soot is just carbons, right? Unburnt hydrocarbons. Unburnt hydrocarbons are carbons. You basically get this carbon as the product. You also get unburnt hydrocarbons. Why do we get unburnt hydrocarbons? Because the oxygen cannot come into contact with all the carbons. The oxygen does not come into contact with all the carbons because the structure is so huge. There is something called hindrance. The structure causes hindrance for this oxygen to come into contact with all of it. So it produces unburnt hydrocarbons. It produces particulates. Particulates are also known as polyaromatic hydrocarbons. PAH, polyaromatic hydrocarbons. And these are the hydrocarbons which is killing our societies. These are the hydrocarbons which is killing our society. The hydrocarbons coming out of the exhaust of these rickshaws, these buses. Have you ever seen the black substances that come out of the rickshaws and buses? These are not that gas is not carbon monoxide. Remember, carbon monoxide is a colorless gas. These are the particulates that are coming out, the polyaromatic hydrocarbons, which are carcinogenic. Carcinogenic means they are cancer causing. These are the death this results in a death of so many people. Yeah, this causes cancer. We don't even know it. That's why whenever you are behind a rickshaw or a bus which has an old engine, sometimes the engine is so old that it is not able to use that oxygen to its advantage, like the old trucks that are used, the old buses that are used, right? So that results in soot, unburnt hydrocarbons, particulates, which are the black dhuan, the black smoke that comes out of the carbon exhaust. And remember, that's not carbon monoxide. Carbon monoxide is colorless. That's why carbon monoxide is also known as a silent killer. It kills you silently at night when you're using a gas heater. So please, if you're using a gas heater, now winters are gone, but in winters when you're using a gas heater, make sure either there is proper ventilation or you have you turn it off at night. And remember, if there is gas load shedding, the natural gas is also toxic. So the natural gas will also kill you. Sir, methane is also silent killer. Absolutely. The natural gas also kills. The soot have a formula. Soot is just C, carbon. Yeah? Carbon. Kala carbon. Oh, that's that. Now, scientists were thinking to themselves, okay, and fun fact. There was once this taxi driver. He did not have enough fuel in his tank, right? So what he did was, I was sitting with him a long time ago when we were young, like around 10 years ago. So he said, hey, I have like matti ka tel. Do you know what matti ka tel is? Matti ka tel is basically kerosene. Kerosene is also a fuel, right? So he had mitti ka tel, and we'll find out how you get kerosene. He had this matti ka tel, and instead of going to a petrol pump, he did not have enough money, so he put matti ka tel in his fuel tank. And the matti ka tel, kerosene, it has a very large structure. So when he started the car started to go like dichik, dichik, dichik. This phenomenon is called car knocking. So car knocking took place. Why? Because the chain was so large that the oxygen could not come into contact with all the carbons, and the engine got kharabified. So please use good petrol, high octane istemal kiya kare. That's better. That's the best. So it's it's much better for your engine ke saath zyati na kare. So now scientists, they were thinking to themselves, Sir, आप टैक्सी भी चलाते थे? No, Arina. So funny, I comedy died. Yeah. Okay. Moving on. Now scientists thought to themselves, What can we do for this? These large chains, these longer chain hydrocarbons, they're becoming a pain in the bum. Yeah, they're not that useful for us. You can't use it because they although they are fused, but they're not more in demand. What can we do about this? Scientists came up with such a beautiful process of cracking. So that's how cracking or pyrolysis was actually scientists transitioned into the concept of cracking and pyrolysis. So what is cracking? Cracking is when these larger chain hydrocarbons, saturated hydrocarbons, when larger, less useful, they're less useful to us. So when larger, less useful, saturated hydrocarbons, which are essentially your alkanes, saturated hydrocarbons, essentially are alkanes, are broken down into smaller, more useful hydrocarbons. And how did scientists do that? Well, they provided it with certain conditions. They provided it with high temperature. And usually, you don't need to know this temperature, but usually it's about like 540 to 550 degrees Celsius. You don't need to know this. They provide it with high pressure. Yeah. High temperature, it's called, when you just provide it with high temperature, it's called thermal cracking. When you provide it with high temperature, high pressure, and you also provide it with a catalyst. When you provide it with a catalyst, is also known as catalytic cracking, because you're adding what is the catalyst? The catalyst for you guys is Al2O3. Aluminum oxide is the catalyst that scientists provided with. In your IGCSE book, I was going through your new IGCSE book. They've also mentioned zeolite. What is zeolite? I swear to God, what is going on with Cambridge? Just stick to one catalyst. Zeolite is Na2Al2SI2OA.XH2O. Who cares? You just need to know the name zeolite, right? So you can either add aluminum oxide, it will totally give you marks. Aluminum oxide, zeolite, or you could also write like chromium oxide. But up until this point, I've just been teaching aluminum oxides. You can just write aluminum oxide and you will get the marks for it. If you're an IGCSE student, you can also write zeolite. It's totally okay. So the pressure is around like 70 atmospheres. You do not need to know these readings. You don't need to know about the temperature. You don't need to know about the pressure. You just need to know that it's high temperature, high pressure, and you have to provide a catalyst, which is aluminum oxide or chromium oxide or zeolite. Done? Then basically, how does this cracking take place? What are the equations? Let's take an example. Your alkenes, like let's suppose dodecane. What's dodecane? Nobody cares. I'll just write the formula. It's C12H26. That's dodecane. Undecane is C11H24. 24, yeah. But that's my alkane. Why is it an alkane? Because it fits the general formula CnH2n plus 2. Who is mixing? Sir, break de. I'm mixing alkanes and alkenes. I haven't even taught alkenes. When you guys were attending this session, I urged all of you guys to forget all the organic chemistry that you know. You just forget all the organic chemistry, right? So we're going to perform cracking. Why? Because the taxi driver, such a dumbo, right? We have to have a solution for him. So the examiner will tell you what are the conditions for it. So we're going to tell him high pressure, high temperature, and a catalyst, which is aluminum oxide. These always, when you're practicing, write the conditions on top of the equation for yourself. Not in the paper unless they are asked, but you write it for yourself so you never forget them. That is what I've been doing since day one. That's why I remember these conditions. You have to write them whenever you are practicing, write them on top of the equation, right? So the examiner tells you, okay, one of the product that has been formed is, let's suppose, C10H22. Write down the other product. He will always give you one product. Or if he does not give you one product, he is going to tell you the name of the product form. Okay, so if one product is C10H22, what is the other product going to be? Simple. It's just minusing. It's just subtracting. How do you subtract it? You have 12 carbons here and 10 are being utilized here. How many more carbons are left? 2. That's it. If you have 26 hydrogens here and you only have 22 hydrogens being used, how many more hydrogens are left? 6. 4. So you have 4 hydrogens left. Ethene is forming. It's simple subtracting. So you took this larger chain, less useful alkane, and you cracked it down, or you pyrolyzed it into, not pyrolysis. You crack this down into 2 smaller chain alkane. You can take this C10H22 and further crack it as well. This is basically your matti ka tel. This is matti ka tel. This is found in kerosene, in matti ka tel, the taxi driver, the tail that the taxi driver was using, right? There can be many possibilities. You know, if your examiner says, hey, write any two products of your own choice. So I can write any two products of my own choice. I'll write an alkane first. So let's suppose I write CH818, right? That's an alkane. Just complete the, just subtract the other carbons. So if you have 12 carbons here, 8 here, subtract 12 from 8, you get 4. And how many hydrogens would you have? 26 minus 18. 26 minus 18, give me 8 hydrogen. मट्टी का तेल पी सकते हैं बिल्कुल आज साहब you can absolutely drink मट्टी का तेल whatever the consequences are I am not responsible for it whatever consequences you feel. Sir, will you cover polymerization? I will cover entire organic chemistry with you guys. Okay. So, okay, and the examiner, I'll give you all the type of questions that he asks. The examiner sometimes says you have C12, H26, propane forms, and 2 moles of ethene forms, write the other product, right? So what are you going to do? Propane is what? Meth eth prop, C3H8, that's propane. He's saying 2 moles of ethene forms. So 2 moles of ethene means C2H4, that's ethene. And sorry, why am I saying ethene? I haven't taught you guys ethene. Sorry. He says 2 moles of C2H4 forms. So 2 moles of C2H4 forms, because I am assuming nobody knows any organic chemistry here. So 2 moles of C2H4 forms, which is basically 2 times C2H4 right here. What is the third product going to be? Please be very careful. Some students make the blunder. They say 3, 2, 5, 12 minus 5. No, 2C2H4, which means you have C2H4, you have another C2H4. So in total, you have 3 carbons, 2 carbons, 2 carbons. How many are left? 5, 5 plus 2 is 7. 12 minus 7, what do we get? 12 minus 7, 5. So 5C5, and how many hydrogens would you get? Well, 26 minus 8 minus 4 minus 4. So 26 minus 16. 16, right? 26 minus 16, 10. C5H10. So the other product is basically C5H10. हाइड्रोजन किधर गया? आसमान में गए. सिर्फ 2 प्रोडक्ट नहीं फॉर्म होते. Not necessarily. There can be tens of products being formed. It all depends on what the examiner is asking. The examiner has told me this forms, this forms. What is the third product that will form? I wrote these 2, and I still noticed that there were some carbons unused, so I wrote the other compound that's left. Sometimes what the examiner does is he says, like you have C2H6, and he tells you 1 organic product forms and 1 inorganic product forms. You need to understand that cracking can also result in hydrogen gas being forming, and hydrogen gas is the inorganic product, right? So H2 is basically the inorganic product. We studied this in inorganic chemistry. So hydrogen is formed. What should be the organic product, everybody? What should be the organic product? So cracking is also a source of hydrogen. C2H6 minus the 2 hydrogens from it, C2H4. So that's the, sometimes he says C10H22 gives you C10H20. What is the other product that is formed? Well, 10 carbons utilized, 22 hydrogens, 20 hydrogens. How many hydrogens are left? 2. It's the hydrogen gas been formed. Yeah. I haven't taught you guys the names of these. What are these products? And these are not alkenes. I'll tell you what they are in a while. So this is cracking, right? And what are the advantages of cracking? Well, we've seen this. The taxi driver, it destroyed his engine. So the advantages of cracking is that shorter chain hydrocarbons. Remember, cracking it is not necessary that cracking will always give you only alkenes. It gives you alkenes, and can also give you hydrogen. That's why I defined it as when larger, less usual saturated hydrocarbons, which are our alkenes, they're broken down into smaller, more useful hydrocarbons. More useful hydrocarbons. I said hydrocarbons because it can either be alkanes or alkenes. What are alkenes? I'll teach you in a while. The ones that are not fitting the formula of alkenes, these are basically called alkenes. These are the birth of alkenes. That's the second family that we have to study. But the advantages are shorter chain hydrocarbons are more useful, or you could say are more in demand. Obviously, they're used everywhere in the petrol pumps from what to what. Yeah? Then it provides a source of hydrogen. Number 3, it provides a source of gasoline. What is gasoline? Petrol. which is petrol. So petrol ऐसे बनता है. This is how petrol is formed. It is CH818, H18 right here. So you could safely say that मट्टी के तेल से petrol भी बन सकता है. Yeah, from kerosene. So you don't need to know that petrol is this C8H18. Number 4, it also provides feedstock for making plastics, which is not an advantage, but I just write it, right? Plastics are polymers. What are polymers? We'll study this later on. Just write it for now. Yeah. What do we mean by feedstock? Feedstock in chemistry, it is not the feedstock that you feed to all the cattle. That's not the feedstock. They are basically, feedstock means raw material. So it provides raw material for making plastic. These substances that are formed, which are not alkanes, these, how do we know they're not alkanes? Because they do not fit the general formula CnH2n plus 2. This is something else. What are these? These are called alkenes. We'll study them in a while. But these substances that are formed right here, they are basically the raw material for making plastics. And that is it. You are done with the entire chapter of alkanes. We're going to move on to alkenes in a bit. I'm going to pause the recording and give you 10 minutes break. We'll continue at 10:40. And don't worry, the entire course will be covered till 1 a.m. or 1:30 a.m. Because alkanes, because I was teaching you the bare basics for alkanes, now you have to absorb this in 10 minutes, and then we're going to continue on with alkenes. Everything is now quite repetitive. Alkenes so repetitive, alcohol so repetitive, and the reactions are simple, very repetitive now. And then we move on to polymerization in the end, and then fuels, and then we are done. Reno. Okay, let me just pause the screen recording. Let's pause the recording. Resume recording. I've resumed the recording, peeps. I've resumed the recording. Okay, one more thing that came up is I asked you guys to remind me of oxygen. Well, in cracking, if I ask you guys, there is also one other condition. Do I have to provide oxygen? Yes, no. Do I have to provide oxygen? Yes, no. Use your brains, please. Yes, 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 yes. Everybody's saying yes. Oh, you dumbos. If you provide it with oxygen, cracking will not take place, because if you provide an alkane with oxygen, they are fuels. They are going to undergo combustion. They're going to undergo combustion. So remember, there should be absence of oxygen. Vacuum में होते है cracking. Vacuum में होता है. So oxygen अगर provide करेंगे तो combustion होगी या combustion होगी. Absence. तेरी ओर. So absence of oxygen. Yeah. तेरी ओर हाय रब्बा. Okay. Let's look at alkenes. Alkenes खत्म हो गए. Alkenes. Oh my God. God, give me the strength, please. It might go on a little longer than 1 a.m., but I'll finish it. Bro. Islamabadi burgers, bro. Do we have Islamabadi burgers with us? Can somebody raise their hands if you're from Islamabad? Burgers? Hey, burgers. Nobody's raising their hand. Even if some are from Islamabad, Islamabadi burgers. Yeah. Okay, alkenes. What are alkenes? Okay, have you ever seen an alkene? Okay, Riz King is saying Islamabad. Your name is showing that you're from Islamabad. Burger. Okay, sorry, that became a little personal. Okay, alkenes. Okay, let's focus here, please. Okay, enough jokes, enough gifs. Okay, alkenes. What are alkenes? Before I teach you what alkenes are, let's look at a few examples that we come across alkenes in our day-to-day life. The plastic is literally the best example of what the plastic is the best example of alkenes. It's not actually an alkene, but it's made up of alkene, right? One of the smallest alkene that you have is basically ethene. That's the smallest alkene with you guys, right? And ethene kidhar aata hai? Ethene basically occurs naturally in fruit. Ethene जो gas है, that's an alkene, and this occurs naturally in fruit. Fun fact. And this, because it occurs in fruit, this causes ripening. This causes the fruit to become ripened, right? Not ripened, ripe, right? And then, this ethene also causes the decay of fruits because it over ripens it. If you let it be on the, if you pluck the fruits and you keep it in a room for some time, so it releases this ethene. It's basically like a hormone inside fruits. जैसे हमारे दिमागों जिसों में hormone होता है, ethene is the hormone in a fruits which causes ripening, and this also later causes on decay because obviously ये overripe होके decay हो जाता है. And fun fact is that whenever you are having these exports, have somebody thought about this? Okay, when these fruit items are being exported, why don't they get kharabified? Why don't they get rotten? The reason is that when they pluck the fruits, they're not even ripe. But when they're exporting it, when they're exporting that fruit, they basically expose the fruit to the ethene gas. They expose the fruit to ethene gas, and it becomes ripened, and then they sell it in the markets, right? So actually, when you're transporting or exporting fruit or importing fruit, you take unripe fruit. Is it unripe? Is unripe the same word? Kharabified means rotten, right? It was Urdu and English mix. Yeah, I was also trying to be like a burger. Yeah, so that's the basic example of ethene. Ethene is also, and alkenes are also used to make plastics. Alkenes are used to make sharab, the pinot drinking, party, booze. Yeah. So all that booze, sharab, alcohol, the drinkable alcohol, it's all made from khamar. Yeah, khamar, it's all made from this ethene. Now, what actually are alkenes? What are alkenes? Alkenes are unsaturated hydrocarbons. What do we mean by unsaturated? What do we mean by hydrocarbons? Hydrocarbon means compounds containing carbon and hydrogen atoms. Please write the word only. Only, right? And unsaturated means unsaturated compounds are compounds having at least one carbon-carbon bond, which is not a single bond, which is not a single bond. And for alkenes, that's the double bond. Alkenes basically have a double bond in them, right? So unsaturated does not mean carbon-carbon double bond. For alkenes, it means carbon-carbon double bond, but unsaturated means that they're compounds which has at least one carbon-carbon bond, which is not a single bond. And for alkenes, it's the double bond. And these two characteristics are going to obviously help us in making the structure or drawing or displayed formula of alkenes. But before we learn that, we need to know how to name them. How do we name them? Pretty easy. I'm going to insert the nomenclature that I have been provided with by IUPAC. And they said that obviously if it's a 2-carbon alkene, it's going to be called eth. If it's a 3-carbon alkene, it's going to be it's going to be called prop. If it's a 4-carbon alkene, it's going to be called bute, pent, hex. But because it's an alkene, the alk bit will be replaced or substituted with the prefix depending on the number of carbons, and the E and E will drop down, right? So eth is a 2-carbon alkene, so eth means 2, and because it's an alkene, the E and E will drop down, 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 and E and E will drop down, the E and E will... So it's ethene, propene, butene, pentene, hexene, heptene, octene, nonene, decene. So if I say what's an 8-carbon alkene called, an 8-carbon alkene is 8-carbon alkene is what? 8 means oct, and because it's an alkene, the E and E drops down. Thank you very much, sir. Sir, do you have ADHD? No, Altaf Saab. I don't. Maybe I do, but I don't. Okay. Now, alkenes are unsaturated hydrocarbons. Let's draw the structures of these alkenes, because let's draw the structure of ethene first. How do we draw? And see, again, the conclusion could very easily be derived. The name tells you two things: the number of carbon atoms and the family that it belongs to. Number, family. Number is 8, family is alkenes, right? Now, if we talk about ethene, how do you draw its structure? Eth means 2 carbons, boom, boom. And because it is an alkene, they are unsaturated hydrocarbons. Unsaturated means at least one carbon-carbon bond is not a single bond, and in case for alkenes, it's the double bond, right? And hydrocarbons mean all the other bonds are going to be with hydrogen, because it will only contain hydrogen and carbon atoms only. So if this carbon has already made 2 bonds, it can only make 2 more bonds, and the right carbon can only make 2 bonds. So that's the structure of ethene, right? It's so repetitive now. Let's draw the structure of propene. Prop means 3, meth, eth, prop. And because it's an alkene, it'll have a carbon-carbon double bond, because alkenes are unsaturated hydrocarbon. Unsaturated means at least one carbon-carbon bond is not a single bond. And for alkenes, it's the double bond. And then that's the single bond here. So complete, and because it's a hydrocarbon, complete all the other bonds with hydrogen, hydrogen, hydrogen. Remember, guys, please do not make the mistake. Please do not make the mistake that carbon can only make 4 bonds. Don't make the mistake of writing another hydrogen.
Shut the hell up.
Honayat Saab, what are you? Who are you talking with? Yeah, Honayat Saab कह रहे हैं shut the hell up. किसके साथ बातें कर? Honayat Saab, chill. You are unmuted. Mute yourself and then talk to your brothers. Okay. Then you have like ethene, propene. Let's talk about butene.
Sorry, sir. Sorry.
And it's okay. But means 4. So you have 4 carbons, and the ENE shows that it's an alkene. They're unsaturated hydrocarbon, right? So 4 carbons, methyl, ether, propa, buta, and because it's unsaturated carbon-carbon double bond, and then you're going to have all the other single bonds, and then complete the bonds with hydrogens because it's a hydrocarbon. It only consists of carbon and hydrogen atoms. Done, peeps? Done. Let's talk about methane for a second. Yeah. Some students always have this confusion. Sir, why why don't we have methane? Janabe wala, methane does not exist. Why does methane not exist, everybody? Because meth means 1 carbon. ENE means it's an alkene. It's an unsaturated hydrocarbon. Unsaturated means at least 1 carbon-carbon bond is not a single bond. Here you only have 1 carbon, so there is no possibility of making a double bond. That's why methane does not exist. The smallest alkene that you have is ethene. Done? And you can make ethene, propene, butene. That's it. That's the displayed formula. I'm going to go a little quick. How do you write the structural formula? Well, the structural formula, that's the displayed formula in which you show all the bonds and all the bonds and all the atoms. In structural formula, what we are going to do is we're going to show each unit in the structure, but we're going to not show any bonds. In alkanes, we did not show any bonds. We're going to show no bonds except for the carbon-carbon double bond. So you have CH2 and CH2, right? So you have CH2 and you have CH2. And what's the bond between them? Because it's a double bond in structural formula, you show the carbon-carbon double bond, right? Similarly, propene ka dekhen, you have CH2, CH, CH3. So we have CH2, CH, CH3. And remember, because it's an alkene, we're going to show the double bond. CH2, then double bond, CH, CH3. Next, CH2 double bond, then you have a CH, then you have a CH2, then you have a CH3, right? We treat all of them separately. CH2, CH, CH2, CH3. Acha, if I ask you to draw it for me, please. CH2 bonded to CH, bonded to CH3. Can we go back into the displayed formula? Absolutely, we can. How? Draw this. CH2, CH, and then draw CH3. And then just complete the bonds. Between the CH2 and the CH, you have the double bond. This should obviously be the single bond. That's it. That's it. So that's how you can draw the structural, you can go back from the structural formula to the displayed formula. That's it. I'm not going to go into more practice for it because it's the same thing we just did, right? You can just do it for any other molecule. Now, let's talk about the molecular formula. Molecular formula kya bolati? It's the number and type. It's the number and the type of different atoms in one molecule. So number and type of different atoms. How many carbons do you have? 2 carbons. And how many hydrogens do you have? 4. How many carbons do you have here? Yes, you may go to the washroom. How many carbons do you have? 4. How many hydrogens do you have? 8. Count it up. How many carbons do you have in propene? 3. How many hydrogens do you have? You have 6 hydrogens. You can count this up, right? So C2H4, C3H6, C4H8. So we can write it here. The molecular formula for ethene is C2H4. Propene is C3H6. Your butene is basically C4H8. And that's how the general formula was also developed. What is the general formula? It is the molecular formula in terms of N, where N is the number of carbon atoms. So here, if you check this out, you have the number of hydrogens are twice the number of carbon. The number of hydrogens are twice the number of carbon. The number of hydrogens are twice the number of carbon. So if I say the number of carbons are N, the number of hydrogens should be twice the number of carbon. That is the general formula for alkene. Sir, why does the first carbon only have 1 hydrogen bonded to it? Can we bond it with 2 hydrogens? Which carbon? Which carbon? This one? This one? Because it has already made 4 bonds. 2 here, 1 here. It has made 3 bonds, so it can only make 1 more bond. After the double bond, it has made 3 bonds. Remember, carbon can make a total of 4 bonds. It has made 2 and 1. 3 bonds are already made. Only 1 more bond with the hydrogen. Okay, so CnH2, and that's the general formula of alkenes. Now, see, in alkenes, we took so long to know all of this. In alkenes, very simple. It's all repetitive, right? That's the general formula. Now, let's talk about how these alkenes are formed. We now know alkenes are, unlike alkanes are saturated hydrocarbons, but alkenes are unsaturated hydrocarbons. Now, how are these alkenes formed? you need to understand that alkenes do not occur naturally, unlike alkanes. And alkanes किधर मिलते हैं? Alkanes are found in crude oil or petroleum oil. Their petroleum or crude oil is a mixture of alkenes. We learn this later on. But alkenes do not occur naturally like alkanes. They're not found in petroleum. Although you can argue to some extent they are, but they're not found to that much extent कि आपकी जो businessman है वो इसको इस्तेमाल करते हैं. So in our books, even they have written that alkenes do not occur naturally in petroleum, although they do, but in a very minimal quantity. So we say they don't occur in petroleum, which is a mixture of hydrocarbons. That's the raw material from which you get your alkenes. We'll study that later on. So how are alkenes formed? We literally studied this above. Alkenes are formed from cracking of alkanes. We literally did this right here. So now I'm not going to discuss cracking again because we've already discussed it. These compounds, now we know what they are. What is this? Meth-ether, 2 carbons. That's your ethene. Meth-ether propobute. That's my butene. Meth-ether, that's my ethene. This is, what is this? Meth-eth probutepent. That's my pentene. सर इस डबल बॉन्ड को आगे पीछे कर सकते हैं? अंबर take a deep breath. Yeah, I'll teach you later on. So that's pentene. That's how your alkenes are formed. How are they formed? From the cracking of alkanes, which we have studied above. We just need to label. We just needed to label this. Yeah. Okay, yeah. So that's all there is to your. Acha, fun fact. You know, once in the exam, the examiner asked, "Can ethane be cracked? Yes, no. Yes, no. Can ethane be cracked? Yes, no." Yes, no.
Yes.
Yes, no, yes, no, yes, no, yes, no, yes, no, yes, no. Sir, ethane is an alkane, even though it has such a small, they're such short molecules, it has such a small structure, even then it can be cracked. And usually when you crack ethane, the purpose of cracking ethane is to obviously get hydrogen gas. That's the purpose. So if ethane is cracked to get hydrogen gas, what should be the other structure that would form? Well, this is C2H6 and you get H2. So what is the other structure that forms? Please subtract it. 2 carbons, none of them are utilized. So C2, and out of the 6 hydrogens, 2 are utilized. How many are left? H4. So C2H4, and how do you draw the structure? C2, and it's an alkene. So alkenes are saturated, unsaturated hydrocarbons. So carbon-carbon means a double bond, and hydrocarbons. All the other bonds are of hydrogen, 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 hydrogen. So ethane can also be cracked. And that's how you can go from alkenes to alkenes. How can you go from alkanes to alkenes? Alkenes is basically the starting point of all the other families. How can you go from alkanes to alkenes? Through cracking. And you know the conditions of cracking. So high temperature around 550, high pressure around 70 atmospheres, a catalyst, which is aluminum oxide or chromium oxide or zeolite, who cares, right? And you need to understand that there should be no oxygen, because if you provide alkenes with oxygen, obviously they're going to undergo combustion reaction, right? And this hydrogen is used in the Haber process. But because getting hydrogen from methane is much cheaper, so the marking scheme also says methane or natural gas. And this ethene, which has been formed, this is later on used to make plastics. Now let's talk about the chemical. Acha, what are the trends in physical properties? It's the same as one we've studied in alkanes. So I'll not be repeating it. What will happen as the number of carbons increases? What will happen to the size? It will increase. What will happen to the mass? It will increase. What will happen to the viscosity? It will increase. What will happen to the volatility? It will decrease. What will happen to the flammability? It will decrease. So on and so forth. We just did all of that stuff in alkanes. So it's the same for all the other families. Next, let's look at the chemical reactions. Chemical reactions of alkenes. Well, alkenes are generally quite reactive. Compared to alkenes, they are quite reactive because remember I told you that alkenes have a carbon-carbon single bond. Their saturated carbon-carbon single bond is more stable than the carbon-carbon double bond. So because this carbon-carbon double bond is not that stable, it will want to break. It will want to break to form carbon-carbon single bonds, right? So that is what the alkenes want to do. Remember, when something is unstable, your entire chemistry is based on the concept of stability. And even entire nature is based on, why are you guys studying? For a better stable future. Everything wants to achieve stability from the macro level to the micro level. Everything wants to achieve stability. So carbon-carbon double bond is unstable compared to the carbon-carbon single bond. Why? I give you a little explanation to that. It's not a part of your course. The electron repulsion is more, right? I showed it to you guys when we were doing alkenes. But that's why it will want to break. This double bond breaks, and therefore it undergoes a reaction called the addition reaction. It's going to add things to itself to break the double bond. How does it do that? I'll tell you. So it undergoes the addition reaction, it undergoes the combustion reaction, and it undergoes polymerization. Polymerization we do in the end. So this in the end. Addition, let's first discuss combustion. Combustion reaction is the same as alkenes. Bilkul same. I just write the equations now. A combustion is what? Any fuel which burns in excess oxygen to give carbon dioxide and water and large amounts of energy. So basically it's going to give me, like, let's suppose I take C2H4 plus O2 gives me carbon dioxide and water. We did this in alkenes, quite a lot of detail. So it's the same thing here. C3H6 plus O2 gives me CO2 plus H2. And I'll write an incomplete combustion equation as well. Incomplete combustion kya? Any fuels which burns in limited oxygen to give carbon monoxide and water and small amount of energy. So C2H4, O2, CO2, and this can also give you particulates and all of that if the structure of alkenes are also too large. So C2H4 plus O2, C3H6 plus O2. It's incomplete, so I'm going to write the equation from the perspective of carbon monoxide and H2O and small amount of energy. So let's balance it. The number of carbons here should be the number of carbon dioxide formed. The number of hydrogens here should be half the number of waters formed. And then you can balance the oxygens. 2 times 2 is 4. 4 plus 2 is 6. So what should I multiply 2 with to get 6? X is equal to 6 over 2. That's 3. That's 3. Okay, here you have 3 carbons. You should have 3 carbons here. 6 over 2. That gives me 3. 2 carbons here. Oxygen's balance, they get 2 times 3 is 6. 6 plus 3 is 9. So what should I multiply 2 with to get 9? X is equal to 9 over 2. The examiner says, please, I do not like fractions. I like whole numbers. So multiply this entire equation with 2 to get whole numbers. We've done this in alkenes. I'm not going to repeat this because we don't have the time, yeah? Okay, it's the same thing. It's the same thing, yeah. And here you can balance this out. I'll just do a few examples. So you have 2 carbons here, 2 carbon monoxide should form 4. 4 over 2, that's 2. Look at the oxygens, 2 oxygens here and 2 oxygens here, 4. So what should I multiply 2 with to get 4? X is equal to 4 over 2. That's 2. Add this here. We first balance the carbons, balance the hydrogens. So in what order do we do balancing? Balance the carbons, balance the hydrogens, balance the oxygen. That's the order, right? But you don't have to follow the order if you know कि जितने atoms ये होंगे उतने moles के carbon dioxide बनेंगे, जितने atoms इस hydrocarbon के होंगे उतने उसके half moles H2O के बनेंगे. And then you just balance the O2. Not now, guys, not now. No questions now. Let me just finish this, right? Then basically you have 3 carbons here. So 3 carbon monoxide forms 6. 6 over 2, that's 3. And now let's check the oxygens. 3 times 1 is 3 plus 3, that's 6. So 6 oxygens on the right hand side. What should I multiply 2 with to get 6? X is equal to 6 over 2, that's 3. That's it. So combustion is the same thing. Now let's look at the butane. Sir, can there be a different balanced equation, right? What do you mean different balanced equations? Balancing is the same for everyone. Sir, so many people are leaving. It's good. I like people to leave. 84 participants, more than enough, yeah. It's obviously you guys don't have the stamina, yaar. Matlab, raham karta hu. I sympathize with all of you guys. Sir, if it says were added to HCl and excess HCl, does it mean excess HCl or the other? I don't know what you're saying, man. Mustafa, this is not related to us. Please do not ask irrelevant question other than organic chemistry. Okay, now let's look at the, we did combustion. Let's look at the addition reaction. Addition reaction. Well, there are 3 to 4 types of addition reactions, right, in your course for alkenes. Number 1 is the addition of hydrogen. Yeah, that's the first type of addition reaction. What do? We take the alkene, which is, let's suppose, methane. We take this butane right here. Hydrogen, ethene, sorry. We take ethene and we add H2 to it. H2 is hydrogen bonded to hydrogen. Now what's going to happen? Well, we know that this double bond is unstable. Unstable means it's going to break. So if this double bond breaks, now check this out. The double bond is broken. It will leave an opening for carbon and this carbon and this carbon. Why? Because carbon can make 4 bonds. Carbon can make 4 bonds here. This carbon has made 3 now. This carbon has made 3. So it's going to say, hey, hydrogen, come here. You can add yourself here. Hey, hydrogen, come here. You can add yourself here. So this carbon is hydrogen or ये hydrogen का hydrogen ja, hydrogen ja, hydrogen a. So these Nice explanation, sir. So this double bond is, although this is so fabricated, in A levels, you're going to learn that whatever I'm teaching you, half of it is lies. These are just stories to make things easier. Okay, so this hydrogen bonds here and this hydrogen bonds here. So what is the new product that forms? This is C bonded to H, H, H. H, 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 H. And these are the new two hydrogens formed. What is this? This was my alkene, everybody. That was ethene. And when we added hydrogen to it, what did it become? It became a saturated hydrocarbon, which is an alkane. So from alkene, you literally went into alkane by just adding H2. Because if you see the difference even in their formulas, alkane is C2H6 and alkene is C2H4, right? So what's the difference? The difference is only of two hydrogens. So what happens is the difference, because it's only of two hydrogens, you add hydrogen, and that's how you beautifully can go from the alkenes to the alkenes. This was ethene, and now you've successfully gone into ethane. But hold your horses. This does not, although the double bond is, sir, is A levels also this easy? Yes. Although the double bond is unstable, there are still certain conditions that you have to provide it. Like, for example, you have to heat it till 200 degrees Celsius. It's 100 to 200, but you have to write an exact value. You can write anywhere between 100 to 200, right? But it's better to write the exact value. So we say heat it till 200 degrees Celsius, and we provide a catalyst, which is nickel solid. We also provide a pressure. We also provide high pressure, which is 150 atmospheres. But in your course, these two are more than enough. Yeah. And if God forbid he asks for a third condition, which he never will, but if God forbid he does, you say 150 atmospheres. But if you are already struggling in remembering the conditions, then I do not suggest remembering this one. It's okay, एक माँ का सदका दे दिएगा अगर तो खुदा ना खास्ता आ गया, लेकिन नहीं आएगा. So that's how you can literally go from alkenes to alkenes, and this is called the addition of hydrogen. That is why it's known as hydrogenation. You don't need to know this. You don't need to know that it's called hydrogenation. I just like to categorize them, right? Ation means addition. Hydrogen means the hydrogen, obviously. Addition of hydrogen. Addition of hydrogen. That's why it's called hydrogenation. It's an addition reaction. In all addition reactions, the double bond is going to break. One more question, one more example. This is a structure of alkene with me right here. Yeah. I just want to test a concept. And now I'm performing hydrogenation, which is I'm going to add hydrogen as my reactant. That's the reagent, but you have to provide certain conditions: 200 degrees Celsius, heat till 200 degrees Celsius, and provide a catalyst, which is nickel solid. What's going to happen, everybody? This double bond right here is going to break. It's going to say, hey, I'm having a mental breakdown like you guys right now because you have a paper. So this double bond is going to break, and this hydrogen is going to be bonded here. This hydrogen is going to be bonded here. So literally you went from an alkene to an alkane. This is C, 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 C. These were the hydrogens which were already, but remember guys, the new atoms, this is very crucial. Write it down on your hearts, on your foreheads, wherever you want to write it down. This is very crucial. Wherever the double bond breaks, the atoms will add there. All the new atoms will add exactly where the double bonds break. So the hydrogens are going to add exactly where the double bonds break, the new hydrogens. Please. Okay, and these were all my old hydrogens, old. So literally went from an alkene into an alkane. So if I write the equation, it's C2H4, and if I add hydrogen to it, I provide nickel solid as the catalyst. What is the reaction? Nickel solid, and you get 200 degree heat till 200 degrees Celsius. What do we get? You just add the hydrogen to it because it's addition reaction. The double bond is going to break, just add them. There's no substitution going on. C2H6, boom. Here you had C4H8. You add hydrogen to it. Yeah, it gives you what? You just add them. That's why it's called addition reaction. Only one product is formed. That's why it's called addition reaction. So what are addition reactions? Reactions in which only, this is a very common question. What do we mean by addition reaction? Reactions in which only one product is formed. In substitution, you were also getting an inorganic product. One was the organic product that you were getting, and one was HCl gas, which is we studied this in inorganic chemistry. That is hydrogen chloride, not hydrochloric acid. Remember, please, it's not an acid, it's a gas. Done? That's hydrogenation. And this is the basis of how margarine is made. Margarine, what is margarine? Margarine is basically butter. You know, it's just a fancy way of saying butter. So margarines are your alkanes. And these margarines, I think it's the same thing as butter. There might be slight difference, but I think it's butter. So yeah, Blue Band Rosanna. These margarines are made from your vegetable oils. vegetable oils. जैसे sunflower oil नहीं होता, these are my vegetable oils. So vegetable oils are alkenes, and this margarine is an alkene. So an example of hydrogenation that you need to know in your course is the formation of margarine. This is an industrial application. Margarine is alkenes. They are saturated hydrocarbons. These are unsaturated. How do you go from unsaturated hydrocarbon to saturated hydrocarbon? By addition of hydrogen, and you provide certain conditions, which is 200 degrees Celsius. You heat it to 200 degrees Celsius, and we provide a catalyst, which is nickel solid. That's done. That's it. Next addition reaction. They're subtypes. It's the same thing. You just break the double bond, add the atoms. Addition of halogens. Halogens are group 7 diatomic molecules, right? Sir, should I remember the conditions? No shit, Sherlock. Obviously, you need to remember the conditions. Organic chemistry mein to hai conditions. Okay, addition of halogens. Let's take ethene. Let's take ethene. Yeah. And we're gonna add a halogen to it, Cl. Let's add a halogen. For this, you require no conditions. If the examiner, God forbid, were to ask you about the conditions for halogenation, why am I calling it halogenation for now? I'll tell you why it's called halogenation. Said the marking scheme just says heat and pressure when it asks for condition. No, you have to write these, please. Whatever I'm saying, just bear with me, right? If the marking scheme something else, just do what you want then. Okay, so what's gonna happen? Well, for this, you require no such conditions. This happens if the examiner, God forbid, were to ask you about the conditions. What's there to remember? It's so logical, man. If you want to rote learn this entire course. Rote learn it, man. It's so logical, yeah? The conditions you need to remember. Okay, if God forbid the examiner was to ask you about the conditions for this, there are no conditions. You can just say it occurs at room temperature and pressure. It occurs at room temperature and pressure and occurs in a dark room. It does not require any sunlight. This is for halogenation. The addition of halogen means halogenation. Halogenation. Ation means addition. Halogen means halogen. The addition of halogen is called halogenation. Okay, so what's going to happen? The double bond is going to break this double bond breaks, and this Cl is bonded here, and the new atoms are bonded exactly where the double bond breaks. Please, it's very important, right? So the double bond will break, this Cl goes here, and this Cl goes here. So what's the product that is formed? C, double bond broke, these were my hydrogens, H, and the new atoms will bond exactly where the double bond breaks, Cl and Cl. So therefore, it's an addition reaction. Why? Because only one product is formed. And if you know this, if you write the formula, that's C2H4 reacting with Cl2, nothing is being substituted. This Cl2 will just add on here. So C2H4 Cl2. What are the conditions for it? No conditions. But if God forbid the examiner were to ask us, it occurs at room temperature and pressure in a dark room. Once, many years ago, he asked, but I don't think he has mentioned any in the syllabus this time. But if God forbid he was to ask you, same as alkanes. These are not alkanes. These are haloalkanes. Halogenoalkanes, right? तो वही alkanes से haloalkanes बने because it has a halogen. Sir, lunch break दे दें, कर लीजिए आप lunch break. Okay, that's it. अच्छा, one more example. I'm just doing the examples that are in your course, right? One more example. I'm adding, let's suppose, Br2 to it this time. Where is the Br2 going to bond? Remember, the new atoms bond, sir, halogenoalkanes or alkenes? These are haloalkanes. Sir, if it forms the same product as substituted alkene, this is a very interesting thing. Let's suppose this question has never been asked in the exam. Let's suppose the examiner gives me something like this, and he gives me something like this. Which one of them would have been formed from addition reaction, and which one of them would have been formed from substitution reaction? Obviously, this is addition reaction. हाँ, आप कह सकते हैं sir, provided assumption मैं बता रहा हूँ कि excess chlorine नहीं था. The difference is UV light and dark room. Yes, this happens at dark room, at room temperature and pressure. Yeah, but that was a substitution reaction. This is an addition reaction. So see, this was through an addition. That's why both the Cl2s are added. See, I'm adding Cl2. एक ये बना, एक ये बना. तो इसमें addition कौन सा था? ये addition था obviously, और ये क्या था? ये substitution था. This has never been asked. Good question. Okay, so this double bond is going to break. This double bond right here is going to break. This Br, one Br is going to be bond here. Br2 means Br bonded to Br. So one Br goes here and the other Br goes here. Remember, the new atoms bond exactly where the double bond break. The double bond breaks, right? So C, boom, 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 boom. And Br bonds here, Br bonds here. The examiner, what he will do is, he's going to tell you, hey, he's going to give you option. एक Br को इधर लगा लेगा, एक को इधर लगा लेगा, एक को इधर, एक को इधर, एक को इधर, एक को तीसरे पे लगा लेगा. तो जाहिर सी बात है, जिधर डबल बॉन्ड टूटेगा, उधर ही, okay, I have to kick AZ out, man. AZ, dude, I'm giving you last chance. I'm giving you last chance. AZ, you are distracting everybody else and everybody is here. You might have studied. Please let all the other students study. If you don't like it, please leave. Yeah. Matlab, why are you guys taking out the old hag person in me? वरना मैं आपको किक आउट कर देना, आप बाकी को डिस्टर्ब कर रहे हैं, सारे जो है पढ़ रहे हैं, आप जो है डिस्टर्बेंस क्रिएट कर रहे हैं. सर कभी शुगल मेला लगाया हुआ है आपने? हाँ, मेरा पठान बाहर ना निकाले. Okay, I don't care, man. At this point, I care for all the students who are in need, not the students who have already studied and are here just to chit chat with me. If you want to chit chat with me, please contact Noor. There is a meeting fee. We can have a 5-minute chat. Okay, so the double bond, and this is called what? This is called addition of halogen, halogenation. That's done. That's it, literally. The third addition reactions are so simple, yeah? So simple. The double bond breaks and they are added. Next, addition of hydrohalogens. What are hydrohalogens? Hydrohalogens, hydro comes from hydrogen, halogen comes from halogen, like HCl, HBr, HI, उनकी addition की बात करें, right? HCl, HR, that's called hydrohalogenation. If you guys want to write it down, hydrohalogenation. These technical words are not in your course. Halogenation, hydrohalogenation, hydration, not in your words. The technical words are not in your. You just need to know they're all addition reactions. So addition of HCl, no conditions. Again, at RTP, and in a dark room. This can occur in a dark room. Done. So you have, let's suppose you have ethene. You have ethene. And you add HCl to it. How will it be added to it? Well, obviously the double bond is gonna break. This H will go here, this Cl will go here. Some students might ask, sir, if we put the H on this carbon and put the Cl on this, will there be any problem? No, sir, it's your choice. Okay, so C bonded to C, the double bond breaks. These are the atoms that were already present, the hydrogen atoms. This might be the Cl and this might be the H. You can simply do vice versa indeed as well. Done? That's it. That's called addition of hydrohalogens, which is hydrohalogenation. And this is, again, what is this? This is a haloalkane that has been formed. Yeah. Acha, what was I going to tell you? I am forgetting. I had to tell you something. Yeah, I had to tell you guys a fun fact, but I forgot. Okay. Acha, write the equation C2H4 plus HCl. What is this going to give you? You just add them, C2H5Cl. Yeah, I was going to tell you that here when we are adding Br2 aqueous, we usually add this in aqueous. Br2 aqueous jo hai, thank you for reminding me. Br2 aqueous is orange in color. Please note that it is not brown, it is orange. If your eyes don't, sorry, it is not brown, it is orange. And because this was orange in color, once it got bonded here, now this orange current will disappear. Now the solution will become colorless. So you go from orange to colorless. Why do you go from orange to colorless? Because no more Br2 is present. The Br2 aqueous orange basically bonded here. It got added here. So the orange color should disappear, should vanish. That's why we say the color changes from orange to colorless, or you could say it, the alkenes, they decolorize bromine water. Br2 aqueous is also known as bromine water. And further, we are going to learn that we are going to use this as a test. It is not red orange, it is not this, it is not whatever, it is orange. No marking schemes are wrong, please. It is orange. I don't know which marking schemes you're looking at, right? So it's orange and it goes from orange to colors. Now there is a new addition in your syllabus. We learned in our A levels, when you go forward and pursue science in A levels, you learn that adding bromine aqueous is not a good idea. But in O levels, we only add bromine aqueous. Every book says this, every marking scheme says this, no marking scheme says brown. हाँ पुराने में कह सकते हैं. Why? Because if you add bromine aqueous is orange. It's gonna go color. Lekin your syllabus now says you can also add bromine liquid. Remember, bromine liquid is now not orange. Bromine liquid is brown. So yes, those of you who say brown to colorless, remember it all depends whether you're adding bromine liquid or bromine aqueous. If you add bromine aqueous and you say brown to colorless, 0 marks. If you add bromine liquid and you say orange to colorless, 0 marks. Please be very careful. Red brown होता है, इसमें हम कहते हैं brown. Right? So please be very careful. This is a new addition in your syllabus and it's given in the IGCSE supplementary part. And even in the O level, it says you can either use bromine liquid or bromine aqueous. But I would suggest stick to bromine aqueous because even when the examiner is asking question, he says when you add bromine to it. So when he's saying add bromine to it, assume that he's talking about bromine aqueous. Unless he specifically says this is called bromine liquid test. See, this was in its aqueous state, ना इसलिए इसको water state में. It's called bromine liquid. ये हम एक टेस्ट के तौर पे इस्तेमाल करते हैं later on to distinguish between alkanes and alkenes. And let's learn that, right? So let's learn how to distinguish between. Let's suppose let we have an alkane. हमारे टीचर तो कहते हैं let we have an alkane and let we have an alkene. And now we're present in the lab. We're sitting in the lab. We're going to add Br2 aqueous here. And we're going to add Br2 aqueous here. Br2 aqueous is orange, right? Will there be a reaction with alkane? Yes, no. Yes, no. Will there be a reaction with alkane? Aqueous and liquid. What's aqueous and liquid? Zan. Aqueous means that when you dissolve it in water. Liquid means that it's its own liquid state. Sir, will there be a reaction? No, sir. Why? Alkenes are unreactive in a room. What will happen? Nothing will happen. So no reaction. हाँ कुछ अफलातून होंगे, कुछ बैठे होंगे, वो कहेंगे सर what if UV light is provided? आपके कोर्स में नहीं टेस्ट करेगा. What if UV light is provided? हाँ फिर substitution होगी लेकिन नहीं होगा. Okay, so there is going to be no reaction. Why? Because we're sitting in a lab, dark room, but we know that alkenes still react. Alkenes will react. So this is orange in color. And this reaction is going to take place and you're going to get a haloalkane out of this. So therefore, since reaction took place, this orange color is going to vanish and is going to become colorless. Orange will become, or you could say the alkene decolorizes bromine. This is called a bromine water test. And for alkene, since there was no reaction, Br2 aqueous is orange. Remember, alkenes are both colorless. They're both colorless. Br2 aqueous, when you add Br2 aqueous, the solution color changes to orange. Visualize it. The solution color changes to orange. So if there is no reaction, what do we say? The orange color stays. The orange color remains. No color change. Remains orange. Done? That's how to distinguish between alkanes and alkenes. Number 4th, addition reaction. That's called the addition of steam, which is basically H2O gas. Remember, it's not the addition of water, it's the addition of steam. That's why it's called hydration. Hydration. Ation means addition and hyd is basically coming from H2O. Polymers aaj ho jayenge, hopefully. If I feel like I'm getting tired, then maybe in the morning I'll do another one. And if I feel like I'm not getting tired, so I'm going to just khadkawafying it. So addition of steam. What happens? You have, let's suppose, an alkene right here. It's basically like, अच्छा वैसे इसकी equation मैंने लिखी है. हाँ इसकी equation भी लिख रहे हैं. So it's basically C4H8 plus Br2. Just add them. C4H8 Br2. Yeah. Okay. So that's my alkene. That's my alkene. Water. What is the bonding of water? Water is H bonded to an OH, right? So what's going to happen? The double bond is going to break. One side will get the H and the other side will get the OH. Sir, which side will get the OH? Which side will get the H? Does not make a difference. Sir, थोड़ा neat लिख लें, word समझ नहीं आ रहे हैं. मैं साथ साथ बोल भी तो रहा हूँ. Okay, so at one point your H is going to get bonded and the other point your OH is going to get bonded. So the double bond breaks, right? So let's break the double bond.
And we know the logic why the double bond breaks, but who cares? So it's your choice. You add the hydrogen here or the OH here, whatever you want, right? Remember one thing. The carbon is bonded to the O, which is bonded to the H. Remember, if you write it something like this, you're going to get 0 marks. Why? Because you're technically telling the examiner that this carbon is bonded to the hydrogen, which is bonded to the oxygen. The hydrogen can only make one bond. Oxygen is in group 6. That's why it can make 2 bonds. And note one more thing. Note. In organic chemistry, people lose marks by not following instruction. Note one thing. सर गलत हो जाएगा साइड्स की वजह से कोई साइड्स की वजह से गलत नहीं होता यू कैन राइट द एच हियर एज वेल इट्स योर चॉइस इफ आई यू वांट यू कैन राइट द एच लाइक दिस इट्स योर चॉइस यू जस्ट हैव टू मेक श्योर दैट द कार्बन इज बॉन्डेड टू द ओ इट्स नॉट बॉन्डेड टू द एच राइट एंड नोट वन थिंग इफ द एग्जामिनर सेज शो ऑल बॉन्ड्स if the examiner says show all bonds, so here you're still not going to get any mark. Why? Because you have to show that O is bonded to H. It's your choice how you want to show it. You can make the bond like this, like this, like this, but you have to show OH means that O is bonded to H. Done? Write down the formula. That's C2H4 and that's your H2O, but remember that's H2O gas. And what will it give me? It will give me C2H4. And remember, I said that whenever we write our molecular formula in the beginning, when we were doing alkanes, I said whenever we write the molecular formula, it's the number and type of different atoms in one molecule, but we write the OH and the COOH separately. Because we have the OH separately, we're going to write this OH separately. So how many carbons do you have? 2 carbons and 5 hydrogens, not 4, 5, yeah? And then you have the OH separately. Do you know what this is? That's my beautiful sharab. But remember, this reaction is not going to take place. This reaction is not going to take place if you do not provide certain conditions. What are those conditions? You have to provide a temperature of 300 degrees Celsius. Please, conditions are so important. Muft ke marks hain. You have to provide a temperature of 300 degrees Celsius and you have to provide a catalyst, which is H3PO4/H plus aqueous. What do we mean by this? It's acidified aqueous phosphoric acid. Please, this is the name. When it says name the catalyst, this is the name, phosphoric acid. Now, those of you who can't remember this spelling, those of you who cannot remember this spelling, note that even if the examiner says name a formula likh de. What is the formula? H3PO4 is phosphoric acid /H plus means it's acidified and aqueous. So formula likh de, mark mil jayenge, but you will not get a distinction. Remember, distinction us बच्चे को मिलती है who follows instruction. The Cambridge examination says, but why do you want to be on the risk side? Don't take the risk. It says name, so name it. It says formula, so formula. If you write the name instead of the formula, he's not going to give you the mark. But if you write the formula instead of the name, he says, yeah, we give the mark. Yeah, we give the mark. But remember, don't put yourself at risk. If he's asking for the name, you write the name. It's very easy. H3PO4/H plus aqueous. So acidified aqueous H. What do you mean by acidified? You add H plus ions to it. So I have good news for everyone. AZ is saying I'm just staying. Okay. So that's what you get. And this is the birth of alcohols. Sharab jo hai, sharab aise banti hai. That's all there was to your alkenes. Itna simple. Acha ji, let's write a summary. What happened was we started off with alkanes, which we obtained from crude oil, which is actually petroleum. Alkanes, petroleum is a mixture of hydrocarbons. What happened was we performed cracking. We take a break of 2 minutes, yeah, or 5 minutes. We performed cracking. And what were the conditions? High temperature, like 550 degrees Celsius, high pressure, and absence of oxygen, a catalyst, which is aluminum oxide, zeolite, or chromium oxide, whatever you want to like. And there must be absence of oxygen. Why? Because if oxygen is present, then obviously combustion is going to take place. That's how you get alkenes. Organic chemistry is all about connectivity. You have to have connectivity. Okay, alkanes ka dusra reaction kya tha, everybody? What was the second reaction for alkanes? Alkanes underwent substitution reaction, right? And what were the conditions for substitution reaction? UV light. Remember, this is how you should revise for organic chemistry one day before the paper. Write the conditions. So UV light, what were you getting? You were getting haloalkanes. Remember, chloromethane, dichloromethane, blah, blah, blah. Then these were the 2 reactions of alkane. And combustions, we don't want to talk about much. We just want to talk about the organic reactions, right? Alkenes. alkenes can go back into alkanes. How? Vegetable oil into margarine. This is vegetable oil is unsaturated, margarine is saturated. How? By adding hydrogen gas to it. And what are the conditions? Nickel solid and a temperature of 200 degrees Celsius. You heat it to 200 degrees Celsius, right? Done. Then alkenes can also go into haloalkanes. How? Through multiple ways. How can it go into haloalkanes? Well, obviously, if you add HCl at room temperature and pressure and in a dark room, you're going to get haloalkane, right? And if you want two halogens bonded to it, if you want two atoms of halogens, you can just add like Cl2, right? And you could also talk about Br2, HBr, HI. I'm just giving you examples. So you either add a halogen, you either add a halogen or a hydrohalogen. So once you add this, both have no conditions. If God forbid they ask about the condition, it's in a dark room at room temperature and pressure. So you're going to get haloalkanes. And the last addition reaction for alkenes was, so these were the 4 addition reactions we studied. 1, 2, 3, and the 4th one is basically going to give you alcohol. That's the birth of alcohol. How does it give me alcohol? You use steam as your reagent, not water. Please, water is not steam. So dark room vagara is not necessary, right? It can also occur in the presence of light. Yes, Mustafa, absolutely. We just want to differentiate it from alkenes, right? We want to say it's so reactive that it occurs in a dark room as well. We are basically saying it is so reactive that it occurs in a dark room as well. Yeah. Okay. So H2O gas is right here. And obviously, what are the conditions? You have like 300 degrees Celsius of temperature. You have to provide 60 atmospheres of pressure. That's the temperature. That's the pressure. And the catalyst should be acidified aqueous phosphoric acid. Acidified aqueous phosphoric acid. Sir, I take my words back. Okay, good. Acha. Now, one more thing. Nowadays, what the examiner is doing, matlab, he is playing psychological games with the students. He's saying, वो आपको ऐसे dash दे देते और इधर लिख लेते kilopascal and students write 60. No, sir. 1 atmosphere, please. And I am writing ATM. You have to write atmosphere, please. ATM nahi likhna. 1 atmosphere has 100 kilopascal. Although it's 101, but in chemistry you round it off to 100. If 1 atmosphere has 100 kilopascal, 60 would have X. X is equal to 60, 100. So it's 6,000. So it's basically 6,000 kilopascal. What if I say kitne pascals chahiye honge? So 1 kilo. Kilo means 3 zeros. So you add 3 more zeros here. So that's what the examiner is doing. So you either say pressure of 60 atmosphere or 60,000 kilopascals. Our cycloalkanes, cycloalkanes are not in your course. And that's it. Now we have formed our alcohols. How do we form alcohols? Well, basically what we do is we take an alkene, and we add steam to it. So once you add steam, what's going to happen? This double bond right here, this is going to break, and this H is going to be bonded here, and this OH is going to be bonded. It's your choice, wherever you want to bond it. This is not in our course. You learned the Markovnikov's rule later on in A levels. Okay, so the double bond breaks. क्योंकि बच्चों को सवाल होते हैं ना, मैं क्या करूं, बताना पड़ता है कि नहीं है कोर्स में. H जितना I can dumb it down, I do it, but the things which are not in your course, then I have to just refrain from it. Now, the OH and H will add exactly where the double bond breaks. So the double bond breaks here, you're going to add the OH. Please, O bonded to H, O bonded to H, show all the bonds. Usually the examiner says, show all the bonds. And remember, if the examiner says, draw the displayed formula, in the displayed formula, we do show all the bonds. Sir, are we not supposed to write 70 atmospheres? No, it's 60 atmospheres. Okay, so you went from C4H8, which is my butene, and you add H2O gas to it. That gave me C4H8. No. What are we going to do? We're going to add the hydrogen and the OH, but we're going to write the OH separately. So one hydrogen has been bonded and one OH has been bonded. So we say ki C4H8, there's one hydrogen added and one OH. We write the OH separately in the molecular formula. That is basically my alcohol. This is basically my alcohol right here. We write the OH separately. That's it. Alkenes are also finished. Why do we write it separately? I'll tell you, inshallah, once we do homologous series. So I'll tell you why we write it separately. Iske bonds hai poor, kiske bonds hai poor. Yeah. That's my alcohol. Zoom out kar dein. Ye le zoom out kar diya. We're going to take a 5-minute break and then continue with alcohol. Alkanes are finished. Alkenes are finished. Now alcohols are 10-15 minutes, then carboxylic acid, other 10-15 minutes, esters, other 10-15 minutes, and then we go on into our organic chemistry. And then we do homologous series and advanced naming and fuels. Maybe in the end, if we have a time and if I have the ability to do so, the capacity, बस थक रहा हूँ मैं आहिस्ता आहिस्ता अब. I'm gonna pause the recording and you guys can ask questions. जी एक सवाल था कि इधर एक हाइड्रोजन कम है. जी हमने लगा लिया. अब हम रिकॉर्डिंग दोबारा पॉज कर लेते हैं. जी अब पूछे सवाल. Okay, hey guys, we're back. So now let's start off with alcohols. We studied that because of the hydration reaction of alkenes, you actually get alcohols. Now, what are alcohols? Let's talk about that. Have you ever seen an alcohol? Obviously, we've all seen an alcohol. Alcohol, we come across it in the Bollywood movies, in the Hollywood movies, maybe for some of us, even in the daily, day-to-day lives, right? No judging whatsoever. But the most basic example of alcohol is ethanol, right? And how is it made? Obviously, it's made from this hydration reaction of alkenes. So you take an ethene molecule and you provide these conditions, which is a temperature of 300 degrees Celsius at 60 atmospheric pressure, a catalyst, which is acidified aqueous phosphoric acid, and you end up with ethanol from ethene, because eth means 2 carbon. Ethanol is obviously going to be a 2 carbon alcohol that's going to be formed from an alkene. Now, the most basic example is in fact ethanol, which is but remember that methanol also exists, right? Although methane does not exist, methanol exists. Some might think, okay, sir, if methane does not exist, how does methanol exist? If you have this question, I'll tell you in the end. But methanol also exists, right? So alcohols, the most basic example is ethanol. It is an alcoholic drink, cool boys, cool boys and cool girls, they might know more about it. So it's used in alcoholic drinks. It's also used in the production of vinegar or sirka, right? It's used in the production of vinegar. It's not vinegar, in the production or manufacture of vinegar. And it's also a good organic solvent. It's also a good organic solvent, right? So certain substances which are not dissolved in water, they can easily be dissolved in alcohols, right? And especially the ethanol, it's a good organic solvent. Solvent is any substance which dissolves a solute. It's the dissolving medium. And ethanol, alcohols in general are very volatile, right? That's why if you've come across a person who has had alcohol, or if you've just come across alcohol in general, you're going to notice that it has a very sharp taste, very sharp smell to it. Why? Because alcohol is very volatile. It is very volatile. So the particles of alcohol can easily escape into the air and reach your nostrils. And because it's very volatile, it's also used as a solvent for glues. ग्लूज में, हेयर जेल्स में, इसमें इस्तेमाल होता है. Why? Because it's very volatile, the ethanol will evaporate and the glue will stiffen. And that's how it's used in glues. Perfumes में बहुत ज़्यादा इस्तेमाल होता है. Aftershaves में इस्तेमाल होता है, because it's also a sanitizer. It can be used as sanitizer. It kills bacteria, right? Cholesterol जो आपकी जिस्म में है, that's also alcohol, because it ends with an OL. So that's also your alcohol. आपके tissues में होता है, आपकी body में, and if the cholesterol levels are very high, you can have an increased risk of heart attack as well. And cholesterol level क्यों high होता है? ये मटन खा के beef mutton, तो इससे cholesterol level high होते हैं. तो please थोड़ा सा cut back on these things, right? It's good for your age, but as you grow older, try to cut back on these things, because this cholesterol is very, very, it is very dangerous for your health. Then these are all the examples of alcohols, right? These are all the day-to-day examples. But what really are alcohols? What are alcohols? Alcohols are basically saturated compounds. They are basically saturated compounds. Saturated means carbon-carbon single bonds only. So they're saturated compounds, but instead they're just like alkenes. Instead of a CH bond, जैसे alkenes का सारे bonds, it's carbon and hydrogen atoms only. This is not a hydrocarbon. And although it's saturated, it's not a hydrocarbon. The only thing, it has the same structure as alkenes. The only difference is that except for one CH bond, एक CH bond will be replaced with an OH bond. That's it. And this OH is basically called the hydroxyl group. No, you don't need to know that it's called the hydroxyl group. but it's hydroxyl. What do I mean by this? Well, this is further going to help us in naming it, right? Naming and making the structures. So just keep this in mind for now. Okay, instead of a CH bond, you're going to have a CaOH bond, and everything else is going to be same. Are alcohols hydrocarbons? No. How can they be hydrocarbons? Hydrocarbons are substances, compounds with only carbon and hydrogen atoms. This also have the oxygen atoms, right? So this, you draw it exactly like alkanes. Instead of a carbon and hydrogen bond, you just put the OH. I'll teach you in a while. But first, let's learn the naming. How do you name alcohols? Well, if the structure is exactly like alkanes and the only difference is that instead of a CH bond, you add a COH bond. So the naming is also going to be exactly like alkanes. The only difference is that instead of an E, we add the OL. That's it. So if I say you have a 1 carbon alcohol, it is 1 carbon alkane is methane, and you cut the E and add the OL. So a 1 carbon alcohol should be known as methanol. A 1 carbon alkane is ethane. If it's an alcohol, you cut the E and add the OL. If you have like a 4 carbon alkane, which is butane. So if I say what's a 4 carbon alcohol, you cut the E and add the OL. That's just the naming, right? And similarly, if I want to make the structure, even let's make propanol, right? So propane is a 3 carbon alkane, and you cut the E and add the OL if you want to name it as an alcohol. Now, how do you make the structure? Make the structure of alkane exactly the same. This is the structure of alkane, H, 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 H. But instead of one H, you add the OH. And please, in drawing the displayed formula, you write the OH, but always show the O bonded to the H. We show all the bonds and all the atoms. Sir, आप macromolecules करवाएंगे polymerization. Macromolecules are polymers, Zana. I'll try my best to do it. I'm getting tired. Maybe tomorrow, but I will try. Let's see where we can reach today. Okay, now let's look at ethane, right? So ethane, and now we want to make ethanol. So we're going to make the exact structure of an alkane. This is an easy way to draw it. Exact structure of an alkane. Instead of an ACH bond, we just add the OH, and then all the rest is the same. All the rest is the same, right? And instead of showing OH as it is in like a group form, you have to show the O bonded to H. You have to show them separately. Try to show them separately. Let's make a butanol. Meth, eth, prop, but. If it were butane, all the other atoms would have been hydrogens. But because it's an alcohol, we add the OH instead of one H, right? And we show the O bonded to H like so. And these are all my hydrogens, obviously. And if I want to show propanol, I can draw propanol. How will I draw propanol? Prop means 3 carbon, meth, eth, prop. Sir, cracking and catalytic cracking is the same thing, yes. Make it go very fast, sir. Okay. Propanol, if I want to draw propanol, you draw exactly propane. Instead of the 1 carbon and hydrogen bond, you add an OH. And it is because of this OH that alcohols undergo certain chemical reactions, right? So again, if I were to name it, the name tells me two things. The propan bit tells me that it has the probe bit tells me it has 3 carbons, and the anol bit tells me that it's an alcohol, right? The OL tells me, basically it's the OL which tells me that it's the alcohol. So whenever you have the OL, petrol is the English name. Petrol is not an alcohol, it's an alkane. Please don't confuse petrol with alcohol. हाँ, बड़ी जाती की थी अंग्रेजी वाले लोगों ने कि इसको पेट्रोल कह दिया, बच्चे कहते oh petrol ends with an O, it's an alcohol. No, petrol is an alkene. It's not an alcohol, it's just an English way. That's not the IUPAC naming. Petrol ka IUPAC naming kuch aur hai. It's octane, right? Gasoline or petrol, they are not alcohols. Okay, so that's basically how you draw it. Now, how do you draw the structural formula? How do you draw the structural formula? Well, you can draw it simply. CH3, there are 3 hydrogens, 1 carbon and 3 hydrogens, and then you have an OH. You have carbon bonded to 3 hydrogens. This carbon is bonded to 3 hydrogens. This carbon is bonded to 2 hydrogens, and OH is written separately. Remember, even in the molecular formula, we write the OH separately. Even in structural formula, we write the OH separately. OH is written separately. CH3, CH2, 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 OH. CH3, CH2, CH2, OH. Yeah. Look at this. This carbon is bonded to 3 hydrogens, and 2 hydrogens, and an OH. This carbon is bonded to 3 hydrogens, 2 hydrogens, 2 hydrogens, 2 hydrogens, and an OH. Okay. Wait, yeah. AZ, Hunayat Saab, I swear, man, you're distracting all the other students. Seriously, please let them study. Do we have to memorize the temperature which each hydrocarbon evaporates? No. भाई जो पढ़ा रहा हूँ बस वो आना चाहिए, वो ये भी अगर आप लोगों ने कर ली तो पूरे मार्क्स आएंगे ऑर्गेनिक केमिस्ट्री. प्लीज डोंट आस्क थिंग्स दैट आई हैव नॉट थॉट येट. ओके. अच्छा, I have a question. I have a question. We'll learn this in advanced naming as well, but I want to give you guys an idea, yeah? I want to give you guys an idea. Just a little idea. This is OH here. And I'm going to add OH here, right? And all the others are carbon. Remember, you have to show the O bonded to the H. Don't write it OH as I am writing it. It's your choice, but it usually says show all the bonds. So be on the safe side, show all the bonds. In polymerization, we don't show all the bonds. Yeah, like we write it OH as OH, we write CO, unless they tell us to show all the bonds. Then, acha, what is the structural formula of this? The molecular formula is the same. This is C3. अच्छा, molecular formula बाद में पढ़ते हैं. Structural formula बनाएं. This पहले इसकी बनाएं. CH3, CH2, CH2, OH. Let's draw this. CH3, CH2, CH2, OH. What is this? It's CH3 bonded to CH and bonded to OH and then bonded to CH3. So that's CH3 bonded to CH, bonded to OH, and then bonded to CH3. Remember, whenever an OH is on top of this carbon, this OH is bonded on this carbon. It is bonded with this CH. So it's like a chain. It's bonded right here. It's not in the straight chain. It's above here, right here. So we add a bracket. Remember, we add a bracket. Why do we add a bracket? We add a bracket because this carbon is bonded to the H and this is the carbon which is bonded to the OH. We tell the examiner not to confuse it. Okay, oh, this CH3 is not bonded to H. This C is bonded to this OH. So we write this in the bracket to show the examiner okay, it is either on top or at the bottom of this OH, right? So this is just an idea. I'll teach you this later on in advanced naming, right? Now, how do you write the molecular formula? Very easy. Molecular formula for methanol should be, we sum all the carbons, we sum all the hydrogens, and we just write the OH separately. So the molecular formula of methanol is the same as its structural formula. The molecular formula of ethanol, so you have 2 carbons, you have 5 hydrogens, and you have an OH, right? 2 carbons, 5 hydrogens, and an OH. Obviously, there are 6 hydrogens and 1 O, but we write the OH separately. Remember this, even in the molecular formula. हाँ, अगर तो examiner आपको एक इतना बड़ा complicated structure दे दे, कुछ ऐसे करके something like this, right? Some complicated, and he tells you write the molecular formula. Then you just sum all the carbons, hydrogens, and oxygens, right? But usually when you're writing for alcohols and carboxylic acid, we write the OH and the COOH separately. अच्छा, तो OH इधर है. How many carbons are there? You have 4 carbons and you have 9 hydrogens and an OH. I can count them quicker than you can. You have 3 carbons, you have 7 hydrogens and an OH right here. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 7 hydrogens and an OH. So if you write down the formulas, the molecular formula, it is CH3OH, then you have C2H5OH, then you have C3H7OH, then you have C4H9OH, then you have C5H, H कितने H's हैं? C5H काउंट करें जरा जनाबे वाला, काउंट करें. रट्टे ना मारे, काउंट करें. OH, and these are my H's. So can we count this please? Count it, everybody. 5 carbons banane, 5 carbons. Right here, 5 carbons, and that's the OH. Please count. You have 5 carbons. How many hydrogens do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 5 carbons and 11 hydrogens and an OH, right? If you notice something, jitne carbons hai, hydrogens are twice the number of that plus 1 OH. Jitne carbons hai, hydrogens are twice. So 3 times 2 is 6, 6 plus 1 OH. 4 times 2 is 8, 8 plus 1 OH. 5 times 2 is 10, 10 plus 1 OH. So can I say, if I want to write the general formula for alcohols, I can easily and safely say that it's jitne carbons honge, the number of carbons which is represented by n, the hydrogens will be twice the amount of that plus 1 OH. And that's the general formula of alcohols. Why do we need to know about the general formula? Well, if I say, okay, sir, what is the molecular formula of an alcohol with 19 carbons? Now, you cannot go and draw all these 19 carbons and then count them. Instead, what we're going to do is we're going to say, okay, in alcohols, jitne carbons hai, hydrogens will be twice the number of that, which is 19 times 2. What do we get? For 38 plus 1. It's going to be twice the number of that plus 1, which is 39, and then OH. So that's the formula. Done, peeps? So that's the general formula, the structural formula, the molecular formula, and all of that stuff. Now, how are these alcohols formed? How are alcohols formed? Well, the first way we learned in our alkenes, it's the addition reaction of alkenes, right? From the addition reaction of alkenes. And it's called hydration. Why is it called hydration? Because we are adding steam. It's the addition of steam. Done. So how does this take place? We have to provide, like, let's suppose we have ethene, C2H4. You add H2O to it, which is in the form of steam. The carbon-carbon double bond breaks. एक side पे H आ जाएगा, एक side पे OH आ जाएगा. So we're going to get C2H5 and OH. That's your ethene. You literally went from ethene to ethanol. Why do I know the name is ethanol? Because you name it exactly like an alkane. You name it ethane because the structure is exactly like an alkane, but instead of the E, you add the OL, right? But not exactly the same, similar. Some students are asking questions, right? Sir, did we skip isomers? GOAT isomers are going to be taught at the end. As advanced naming isomers. इसके बाद alcohols के बाद we have to do carboxylic acids, then we have to do esters, then we have to do homologous series, advanced naming and isomers. And then we're going to go and do polymerization. Okay, so you went from it, but remember you have to provide certain conditions. What are the conditions? Temperature of 300 degrees Celsius. You have to provide acidified aqueous phosphoric acid, and you have to provide obviously a pressure of 60 atmospheres. 60 atmosphere or 60,000 kilopascal, whatever you want to like. Yeah? You can add either or, because no, not 60,000, 6,000, my bad, because 1 atmosphere is 100 kilopascal. So 60 into 100 gives me 6,000, not 60,000. Thank you. Great. Now, know one thing, guys. Know one thing. Listen. This is not actually an irreversible reaction. ऊपर तो हम बस forward arrow से represent करते हैं, but this is not actually an irreversible reaction. This is a reversible reaction. So reversible reactions are represented with a forward arrow and a backward, which is, this information is not that useful. It doesn't make, it's just but it's good that you know that it's not a reversible reaction. It's not an irreversible reaction. It's a reversible reaction. You know all the concepts of reversible reactions. But the beauty is that you almost get 100% yield. 100% yield ka matlab kya hai? If you had 100 molecules of ethene, they almost converted into 100 molecules of ethanol. But usually we get 96%, 97%, 98%, but you can also maximize it to 100% as well. So that's why we don't care whether it's reversible or irreversible, but you should know that it's a reversible. So that's one way of making your alcohols, right? And it's not just ethene. You can literally take anything else. You could take propene or butene. Let's take butene. You add steam to it. What's the alcohol that's going to form? What's the alcohol that's going to form? You're going to form C4H9OH, right? And if I want to draw the structures, you can literally draw the structures as well, right? You don't have to break the bonds and all of that stuff. You don't need to break the bonds. Why? You don't need to break the bonds. Why don't you need to break the bonds? Because we know that the structure of alcohol is just like the alkene structure. So just make the structure of alkene. Just make sure that you add the OH where the double bond breaks. So you can add it here or here. It's your choice. So let's add the O bonded to H here and all the other hydrogens as it is. Yeah? So don't even have to say कि double bond break ho gaya, wo ho gaya. Sir, can you send this in the group chat, the notes? Sure. But again, certain conditions. The second way is making it at home. I'll teach you how to make alcohols at home, but I do not condone any of this. I do not condone this behavior. Please, parents, don't make your parents call me. It's a part of your syllabus. I can't do anything about it. The second way is through fermentation. Fermentation of glucose. What is fermentation? Well, okay, tell me something. Which alcohol do you want us to make? Strawberry flavored, grape flavored, which alcohol? आप try करें जो करना है करें भाई जो मर्जी. Grape flavored, let's make grape flavored alcohol. So what we do is we take grapes. This is what happens at home. So we take grapes and we crush them. We crush them and add water to it. You crush them, add water to it, and then you make sure that the container is airtight. You make sure that the container that you're doing this is airtight, and you also add yeast to it. So first you add yeast to it, which is khamir, which is पश्तो में उसको क्या कहते हैं? पश्तो में yeast को कहते हैं तोमना, and Urdu में कहते हैं खमीर, and English में is yeast. It's like a bacteria. It's an enzyme, not bacteria, enzyme. Yeah, bacteria, but it's like an enzyme, right? It acts like a catalyst, but since it's living, you call it an enzyme, not a catalyst. They are catalysts, but enzyme is the better word. All living catalysts are called enzyme. Enzymes are biological catalysts. Okay. So you add yeast to it and you make sure that your container is airtight. And then what you do is, मट्टी के कंटेनर में अक्सर आप इसको बना सकते हैं. ग्रेप्स लें, उसमें पानी डालें, खमीर डालें, थोड़े दही. खमीर किधर से, where will you find खमीर? You either buy it from the stores or you can just put some yogurt in it, because yogurt actually contains khamir. Khamir yeast actually converts the milk into yogurt. That's the yeast is that bacteria which does that. So you make sure it's airtight and you bury it underground. You bury it. This is I'm teaching you how you make it at home. You bury it for like 10 to 15 days. If you want to make sure that it's very nice, 10 to 15 days, 5 to 6 days, if you just want to make sure it's yeah. And then you're going to get your drinkable alcohol. Remember, ethanol is the only drinkable alcohol, and that's how you can get them. Now, this entire process is, will the alcohol be halal? Bhai piyo jo karna hai karo. Okay, so this is the entire process of making alcohol at home, and this process is called fermentation. Now, why did I perform these certain procedures? Let's look at them step by step. So what was in grapes why did I use grapes? Obviously for the flavor to be grapes, but grapes actually has glucose in it. Right? And you add water to glucose, it becomes aqueous, obviously. And then I'm adding yeast to it. So yeast is my first condition. It's the enzyme. It acts as a catalyst, but we don't call it a catalyst. We call it as enzyme, right? So it's our enzyme. If it says, what is the catalyst for fermentation? It's yeast. So it's yeast. It gives you ethanol and carbon dioxide, but not just yeast. You need to make sure that you bury it under the matti. Why? Because under matti, you need to understand, just beneath the ground, you have a temperature of 25 degrees Celsius to 35 degrees Celsius. That's why you bury it directly under matti. Thoda sa matti ke niche isko bury kare. So you're going to have a temperature of 25 degrees Celsius to 35 degrees Celsius. And I'm just going to write 35 degrees Celsius. You have to mention a particular temperature. The examiner says आप 25 to 35 degrees Celsius लिख सकते हैं, but it's better to just mention a temperature in this range. So I'm going to say a temperature of 25 to 35 degrees Celsius. No, it's not 37. It used to be 37 in the syllabus. Now the syllabus has changed. It says 25 to 35. In the previous papers, it was 37, but now it says 25 to 35. So it's 35, right? So it gives me carbon dioxide. Now, what happens? There might be certain questions. That's it. That's how glucose. So glucose is C6H12O6, and you add water to it. So it's obviously aqueous. What are the conditions? You add yeast to it and provide a temperature of 35 degrees Celsius or 25 to 35 degrees Celsius. And you note one thing, that there should be no oxygen, absence of oxygen. Why? Because we have to make it airtight. Why should there be absence of oxygen? I'll tell you in a while. I'll tell you all the whys. You're going to get ethanol. Ethanol is C2H5OH, and you're going to get carbon dioxide. You get 2 moles of ethanol and 2 moles of carbon dioxide. Ethanol is my liquid, carbon dioxide is my gas. Yeah? Done. Grapes are out of seeders. Can we make it with sugar? You can take any fruit. You can make it with any fruit, because all fruits contain glucose, right? Let's just add this... just move this a little here. Now, if the examiner is going to ask you, how will you describe this? First, let me tell you the reasons for everything. Why do you have to have a temperature of 25 to 35 degrees Celsius? Because yeast is an enzyme. Those of you who are bio geeks, this is only for bio geeks. Those of you who are bio geeks, you know that yeast is an enzyme. So an enzyme operate at optimum temperature. And because they operate at optimum temperature, you have to provide it with that temperature. Above the optimum temperature, the enzyme can get denatured. Yeah? Denatured ho sakta hai, kharab ho sakta hai enzyme, which is around like 40 degrees Celsius. If the yeast reaches a temperature of 40 degrees Celsius, it gets denatured. Khatam, tabah barbad, right? Why are we adding water to it? I'll tell you in a while. So yeast gets denatured. Now, if it's below 25 degrees Celsius, you know that enzymes become inactive. You know, bio geeks, inactive enzymes become inactive if it goes below 25. This is only for bio geeks, and above it can become denatured, right? So that's the reason for temperature. Why should there be absence of oxygen? The reason why there should be absence of oxygen is because yeast respires anaerobically. Only for bio geeks. What do we mean by anaerobically? Anaerobic means that there should be absence of oxygen. Humans, we respire aerobically. But sometimes when we work out a lot, then we also start to respire anaerobically. हमारे जिस्म में lactic acid बनता है वालाना टिमकाना. लेकिन ये सिर्फ bio students के लिए कह रहा हूँ. There should be an absence of oxygen because yeast is an enzyme and this respires anaerobically. So the yeast, because you are not giving it oxygen, the yeast will use this sugar for energy instead of oxygen, and it will respire without oxygen, obviously, and this sugar will be broken down into carbon dioxide and ethanol. Lactic acid दूध नहीं होता. नहीं भाई. Easy man, chill. I'm getting tired. I swear. सर रिमूव कर दे. नहीं बेचारा पढ़ रहा है. लैक्टिक एसिड जेन्युइन सवाल हो सकता है. जेन्युइन सवाल हो सकता है. ओके. जेन्युइन सवाल हो सकता है. आई एम नॉट डूइंग एनीथिंग. ओके, इट्स फाइन इजी. यस जेन्युइन सवाल हो सकता है. मैं थक गया हूँ genuinely. Okay, why do we add water to it? Well, the reason why we add water to it is that we want this alcohol that is being made, this ethanol, we want that to be almost 15% concentrated. It's very dilute. We won't even call it concentrated. We want the ethanol that is made to be dilute. Only we want to have a dilute solution of ethanol. Why do you want to have a dilute solution of ethanol? Because guys, if this is all logical, conceptual, जितना आप लोगों ने समझना है इसको, ये आप लोगों की information is just for your information, all the whys. The thing is that if you do not add water to it and you just take glucose and yeast and this, the ethanol that is going to be made is going to be very concentrated. And if the ethanol at the start is at a higher concentration, it will kill the yeast. It will kill the yeast. So yeast is going to be like khalas. Ethanol is a good antiseptic. It is used in sanitizer. It kills bacteria. So it's going to kill this yeast. That's why we add. Sir, ethanol is highly volatile. So will it not evaporate? You airtight it. So it'll be there, right? So these are all the reasons which you do not need to know. I just said it because some students usually ask these questions. So I give you all the explanation beforehand. Now, how do you describe it? This is the main thing. It can come for 6 marks. And this time I reckon it might come in the ATP. How do you describe the process of fermentation? You can't say, Sir Suleiman took glucose and this. You just simply say, okay, add water to glucose. Add water to glucose. Then what happens? You add yeast and provide a temperature of 35 degrees Celsius. और bracket में आप लिख सकते हैं 25 to 35. All good, yeah? And then what do? Then we perform fermentation. Fermentation takes place in the absence of oxygen. इसको fermentation कहते हैं. The glucose is fermented into ethanol. Fermentation takes place in the absence of oxygen. बल्कि don't write it like this. Write it like this कि there is absence of oxygen. You don't need to write the Y's. The Y's were only for you. Fermentation takes place to give ethanol and carbon dioxide. And then the 6th mark or the 5th mark, the 6th mark is this is the 2nd mark, and that's the 3rd mark. Yeah. And the 6th mark should be, I should write 3 here. I should write 4 here, 5 here. And then the 6th mark should be of like the equation. So you say C6H12O6 gives me, this is aqueous, gives me C2H5OH and carbon dioxide. That's it.
Sir, part 4 क्या है?
Part 4 क्या है? Absence of oxygen. Because yeast respires anaerobically, right? Now, you
Yes, sir,
also
thank
need to understand that is the reason why ethanol is the only drinkable alcohol. Whenever you have glucose, ethanol is going to be it is going to be fermented to make ethanol. Ethanol is the only drinkable. इसलिए आपने newspapers में देखा होगा. I always see newspapers में बहुत सालों पहले आता था कि फलाने इतने लोग, so many people lost their lives because of basi sharab. So basi wo basically ये होता है कि they are not ethanol. They use either propanol, methanol, something else, which can literally kill you in seconds. In seconds. So ये जो detol, one of my students once what he did was detol के पीछे methanol लिखा, तो उसने कहा सर ये तो alcohol है, मुझे चढ़ जाएगी. उसने पीने शुरू कर दिया. मैंने कहा पागल हो, it's gonna kill you, man. So chill out. Sir, they don't recommend bullet points. Zainab, I don't know if you're living under a rock. They do recommend bullet points, and I've sent the examiner reports in the group chats where it clearly states that write it in bullet points. I don't know which teacher tells you these things. मतलब पाकिस्तान का कोई हाल नहीं है, हर बंदा अकले कुल बना हुआ है, एक इंस्ट्रक्टेड कोर्स कोई फॉलो ही नहीं कर सकता कोई टीचर. बस मेरे तो ये जो मेरे से पढ़, जो मैं कह रहा हूँ वो कर ले, नहीं करना अपने टीचर्स को फॉलो करे. Seriously, man. Seriously. Okay, so then you write the equation and that's it. So ethanol is the only liquid, and that is, acha, masla kya hai? Masla isme is, this entire process has a masla in it. What is the masla? The masla is that you get a dilute solution of ethanol. So if you want to make this solution concentrated, a seventh point could be perform fractional distillation. Perform fractional distillation to obtain a higher concentration of ethanol, because this ethanol is going to have like your 15%, it's only going to be 15% ethanol and the other 85% is water. So you perform fractional distillation to get pure ethanol, to get almost 99% of ethanol, right? The purity, the higher, we want to increase the concentration of ethanol. Why would we want to increase the concentration of ethanol? Well, obviously we want to increase the concentration of ethanol to use it in alcoholic drinks, to use in beverages, in beers, in all of that, all of that good stuff. No, not good stuff. Astaghfirullah, haram, okay? So that's what we do. We perform fractions. That's a limitation of this reaction. And that is why we say that it is a batch process. What do we mean by a batch process? A batch process means that obviously, firstly, you have to make this ethanol and then you're going to have to do it in shifts. So you make it and then you take it to the fractional distillation chamber. You make it and then take it. So this makes the process very slow. Why? Because let's suppose this is A and this is your machine number A and that's your machine number B, right? And this machine takes 5 minutes to ferment it. Let's suppose, just as an example, this takes 5 minutes to ferment it. And for fractional distillation, you need 10 minutes, right? This is fractional distillation. So this will take 5 minutes to ferment it. This will take 5 minutes. So for every one batch that has been fractionally distilled, 2 batches would be made. So this is going to make the process very, very slow. That is what we mean by batch process, a process where each batch goes through one stage of production process before moving on to the next stage of the production process, right? So it is, because it is a batch process, it is very slow. And that is why the syllabus wants us to, it is slower compared to hydration. That's why the syllabus wants us to know the advantages and disadvantages of fractional, of fermentation and hydration. Well, the advantages are very simple. For fermentation, compared to hydration, I'm comparing the two, right? Compared to hydration. So what's the advantage of fermentation? The first advantage of fermentation is that it has a lower energy consumption. Energy consumption. Why does it have a lower energy consumption? Well, it has a lower energy consumption compared to hydration. Why? Because hydration, you had to provide a temperature of 300 degrees Celsius. For this, you only need to provide a 35 degrees Celsius temperature, a 37 degrees Celsius temperature, a 25 degrees Celsius temperature. So less energy is needed compared to hydration method, right? Next, the second advantage could be is that it uses readily available materials. It uses renewable resources. Glucose is renewable. Glucose is renewable. Or you could say, और कार्बोहाइड्रेट, इससे बेहतर है ग्लूकोज की जगह कार्बोहाइड्रेट्स लिख लेना, लेकिन ग्लूकोज बेहतर है, राइट? सो ग्लूकोज इज रिन्यूएबल, और यू कुड से इट यूजेस readily available resources. Please, guys, the examiner report that I shared with you guys in the discussion forum, it clearly said that student got no marks who said fermentation is renewable. But fermentation is not renewable. Fermentation is a process. Glucose is renewable. Don't make this mistake of writing fermentation is renewable. No, 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 no. Glucose is renewable, right? Is this an industrial method compared to fermentation? Yes, it's mostly in the industry. You're right. These are the advantages of fermentation. But what is the disadvantage? What is the disadvantage? Let's add the disadvantage here. It's a batch process, which means it's slower. So disadvantage, advantage, disadvantage. Disadvantage क्या है जनाब वाला? It's a slow process. It's a slower process. Slow की जगह slower, because we're comparing the two, so we need to add the word slower. It's a slower process compared to hydration. Yeah, it's a slower process. You can also say you could say this. You can also say that it's not a continuous process. Yeah, it's a batch process. अगर आपने दो disadvantages लिखने, एक ही major disadvantage is a slow process. Why is it slow? Because it's a batch process. लेकिन अगर दो बनाने हैं तो लिख सकते हैं it's not a continuous process. Yeah. Next, what is the advantage of hydration? First, let's write the disadvantage. The disadvantage is what? See, because fermentation uses lower energy, fermentation has lower energy consumption. So the disadvantage of hydration is that it has a higher energy consumption, right? So just जो fermentation की advantages है वो hydration की disadvantages बन जाएंगी, right? So it has a higher energy consumption. Yeah, greater, higher costs. And number two is that this requires readily available resources like glucose, and it's also renewable. But for hydration, you need to get ethene as your raw material, and ethene needs to be obtained from cracking, and ethene is a non-renewable resource. It is a finite source. So we use ethene, which ethene is a finite source. Finite means it's going to deplete and not readily available. Done? Fortnightly finite. Finite means it's gonna deplete. It is non-renewable. It is non-renewable. You could just write ethene is non-renewable. Yeah. And the advantages of hydration. Hydration is a continuous process. जैसे जैसे बनता जाता है शराब वैसे वैसे डालते जाते हैं बोतलों में. जैसे जैसे बनता जाता है, it gives you about 96% purity. Fraction इससे कितनी बार fermentation से 15% आ रही थी. You were getting a dilute solution of ethanol, and then you had to perform fractional distillation to make it more concentration. Here you get almost about 96-97% of purity. So it is a continuous process. That's the advantage. It's quicker. Continuous process लिख लें, but the advantage is, what is in continuous process that it is an advantage? Because it is a quicker process. It's quicker. Why is it quicker? Because it is a continuous process, quicker process. Done? जैसे जैसे बनता जाता है वैसे वैसे डालता जाए. एंड अगर आपने लेट सपोज वो आपको दो एडवांटेजेस लिखने को दे दे तो इन दोनों को तोड़ दें. जस्ट राइट इट्स अ क्विकर प्रोसेस एंड इट्स अ कंटिन्यूअस प्रोसेस. यू कैन ब्रेक देम डाउन एज वेल, ऑल्दो दे बोथ मीन द सेम थिंग. That's it. You can also say sustainability. You get a higher yield, about 96% compared to fermentation. लेकिन चूंकि fermentation की बाद में आप fractional distillation कर सकते हैं तो उसको तो आप convert कर सकते हैं ना. So that is how alcohols are made. You need to know how to describe the formation of alcohol just by writing these simple points. Literally the equation. You need to know the equation and how they're formed from hydration and fermentation. That's it. और घर में हम labs में demijohn flasks भी इस्तेमाल करते हैं. सर आप मोल्स करवाएंगे, मेरे में हिम्मत हुई तो करवा दूंगा यार, क्या हो गया. Now there are chemical reactions of alcohols. Let's finish alcohols, please. There are certain chemical reactions of alcohols. What are the chemical? Remember, the physical trends are the same. The trend in physical property is the number of carbon increasing, blah, nah, timkana, blah, nah, timkana, all of that good stuff. Sir, can you show the hydration process for a second? Sure, Rafi. Yes, we discussed this above in alkenes. It's okay, कल इसको fresh दिमाग से एक दफा जब देखिएगा आप लोग तो it's all going to be good. Okay, chemical reactions of alcohol. Number 1, combustion. Number 2 is like oxidation. And number 3 is your esterification. Done? So if we talk about combustion, same thing. Because alcohols are fuels, they can be used as, because they burn in oxygen, they can be used as fuel. So combustion reaction, any fuel which burns in excess oxygen to give carbon dioxide and water and large amounts of energy, and it undergoes incomplete combustion and complete combustion, depending on whether you have limited oxygen or you have excess oxygen, or if there's another type of incomplete. We've all studied combustion, right? So I'm just going to write the equations for you guys. So CH3, just balancing it for you, right? CH3OH plus O2 gives me carbon dioxide and water, same exact as alkanes and alkenes. C2H5OH plus O2 gives me CO2 plus H2O. C3H7OH plus O2. I hope you can balance it. Balance the carbons first, then the hydrogens, then the oxygen. Or if you have if you've learned the concept कि जितने carbons होंगे उतनी carbon dioxide बनेंगे, जितने hydrogens होंगे, you have 4 hydrogens. So here the hydrogens should be, so remember there are not 3 hydrogens, 3 is here and 1 is here as well. So there are 4 hydrogens, so H2O should be half of this, and then you just balance oxygen. So 1 times 2 is 2, 2 plus 2 is 4. What should I multiply 2 with to get 4? X is equal to 2. So we get 2 right here. Then literally you can balance out anything. You have 2 carbons here, so 2 moles of carbon dioxide form, 6 hydrogens here. So half of 6 water, half of 6 to find the moles of water form, which is 3, right? And then balance the oxygens. 2 times 2 is 4, 4 plus 3 is 7. So what should I multiply 2 with to get 7? X is equal to 7 over 2. The examiner does not like fractions in O levels, although it's completely acceptable, but to just be on the safe side, multiply the entire equation with 2, right? What's the time in your country? It's 50 a.m. And then similarly, you could do it for this one as well. And incomplete, I'll do this for incomplete combustion. Let's suppose incomplete combustion is taking place. So carbon monoxide and water will form. You had 3 carbons here, so 3 carbon monoxide should form 8 hydrogens. So half of 8 is 4. 4H2O should form. And how many oxygens do you have? How many oxygens? 3 plus 4, 7. You already have, oh, wait. Chill. This is wrongly balanced. This is not balanced correctly. Why? Because you guys had 7 nobody corrected me. You guys had 7 oxygens on the right hand side. 2 times 2 is 4 plus 3, 7. You already have 1 here. So how many more oxygens do I need? What should I multiply 2 with to get 6? Because you already have 1 here. Please make sure you don't make this mistake. Similarly here, this is not correctly balanced. Yeah, nobody corrected me. Thank God I did the balancing. Yeah. So you have 3 hydrogens on the left hand side, on the right hand side, and you automatically have 3 on the right. So this is automatically a balanced equation. My bad. Yeah. And here, GG. Somebody ask a question? Okay, so you have 7 oxygens on the right, and you have 1 oxygen hidden right here. So you need 6 more. So what should I multiply with to get 6? You get 3. My bad. So there's no 2 multiplication. Nobody correct. GG.
लेकिन the first equation में तो hydrogen balance नहीं हुए.
Oh, yes, you can balance this. Yeah. Here. Happy? 4 hydrogens?
जी.
4. Half of this. And then you have like your 3 times 1 is 3 plus 4, 7 oxygens on the right hand side. And how many oxygens will you have on the left? Reno. How many oxygens? Well, you already have 1 here. So how do you balance this? What should I multiply 2 with to get 6? You need 6 more. So 3, obviously, right? 3 plus 4, 7. And,
Sir, chemistry 3 दिनों में हो जाएगा.
Sorry?
Chemistry 3 दिनों में हो सकता है.
हो सकता है. मेहनत करें हो जाएगा. मेरी energy down हो रही है, down. Yeah. So that's the balanced equations for it, right? So you can balance it very easy. Just make sure you know that this tiny little thing is hidden here, which I did not notice at first. Yeah. It went unnoticed. My bad. And you can also check your equations, right? So you check 4 hydrogens, 3 oxygens, and how many? Oh, you also have to balance this out now, right? So 2 plus 2, that's 4. And you already have 1 here. So 2 को मैं किससे मल्टीप्लाई करूं कि कितने आए 3, ये भी बैलेंस नहीं है, right? So 2 plus 2, that's 4 oxygens here. 1 is already here. You need 3 more. So x is equal to 3 over 2. And since your examiner does not like fractions, you multiplied this equation with 2. So you're going to get the balanced equation. Similarly, you can check this. 7 oxygens here. 2 plus 2 times 2 is 4. 4 plus 3 is 7. 6 hydrogens, 2 C's, 2 C's, 3 C's, 3 C's, And how many oxygens do you have? 3 plus 4, 7. And you already have 1 here. So you need 6 more. 2 को किससे multiply करूँ 6 आए? 3 से. Sir, one lumpy break after alcohol, sure. So that's how, just make sure that this sneaky little thing does not go unnoticed when you're balancing the equation, yeah? Okay, the second is, basically we're done with combustion. This esterification we will do after carboxylic acids. So we're just left with one more reaction, which is oxidation. Sir, are we supposed to write /H plus if they asked up the formula of acidified potassium manganate? Yes, Vanya. Students don't do that, they end up losing marks, especially in O levels. Okay, so the next example of alcohols is an oxidation reaction. What is oxidation? Basically, what we do is, because of the OH group, because of the OH right here in the alcohols, they undergo this particular reaction, which is an oxidation reaction. Just like alkenes have the double bond, because of the double bond, they undergo specific chemical reactions, which are called addition reactions. Just like that, there are OHs here, and OH basically determines why OH is the function. No, I don't want to use the word, but OH is the group of atoms which determines its chemical property or chemical behavior, which is undergoing oxidation. Now, for oxidation, you need to have certain conditions. You need to have an oxidizing agent for it. And the oxidizing agent in our course is KMNO4/H plus aqueous. Remember, you have to write /H plus. What does this mean? This is acidified aqueous potassium manganate, right? And if you want to write the name, please know the name as well. Acidified aqueous, UEOUS, potassium. K means potassium, right? And MnO4 is the manganate ion. Potassium manganate 7. 7 is the oxidation state of manganate. So this is the name that you have to write if they asked you for the name. If it's very difficult, you just write the formula, but don't put yourself at a disadvantage. Done? So you have to provide this, and you also have to just heat it a little bit. So what's going to happen? Well, in redox, remember in redox, I used to teach you guys something. In redox, I used to tell you that the loss of hydrogen atoms is oxidation. The gain of oxygen atoms is oxidation. The loss of hydrogen atoms is oxidation. And I told you guys this, we are going to use this later on in organic chemistry. In inorganic chemistry, we don't use this gain loss. We use oxidation state or gain or loss of electrons, right? Increase or decrease in oxidation state. Okay, here now we are going to use the concept of gain or loss of hydrogens. Now, what happens? Basically, and later on, I'll teach you shortcuts as well. Basically, what happens is, to dumb it down for you guys, the oxidizing agents, first of all, we know that oxidation is the loss of hydrogen atoms. So the hydrogen in the OH and one adjacent hydrogen, the hydrogen in the OH and one adjacent hydrogen, they are going to be lost right here, because oxidation is the loss of hydrogen atoms. But once they are going, they're like going away. Hey, I'm going, this bond will finish, right? So here they're going to be like, hey, I'm going. The KMnO4 says, hey, don't worry, I'm an oxidizing agent. I will also give you an oxygen atom. The KMnO4 gives it an oxygen atom, and what is formed, everybody? H2O is formed. It's totally dumbing it down for you guys. So these two hydrogen atoms are lost because oxidation is the loss of hydrogen, and the KMnO4 gives it one O, right? And that's why the symbol for oxidation is always bracket mein aap O likhte hain, which means that oxidation is taking place. So it gives it one O. The KMnO4 is basically giving it an O. So isko O de deta hai, H2O forms. Now the carbon has now made only 3 bonds. So what it does is it wants to satisfy its 4 bonds. And since you have a single bonded oxygen right here, oxygen kitne bonds banata hai? 2 bonds banata hai. So this oxygen is unhappy, this carbon is unhappy. They'll be like, hey, we are going to make each other happy. We are going to make each other happy by making a double bond between us. So ye double bond bana lete. Lekin KMnO4 kehta hai, wait a second. I am also going to give you one oxygen, my dear friend. तो ये हाइड्रोजन को थोड़ा सा साइड पे करके KMnO4 इसको भी एक ऑक्सीजन दे देते हैं. So three things happens. What 3 things happen? Number 1, the the alcohol that you had, the OH and H, these H2s were lost and the KMNO4 gave it an oxygen to form H2O. And because the bonds were not complete, there was a double bond between carbon and oxygen to make them happy, and KMNO4 gave one oxygen where this double bond was made. तो एक oxygen इनको भी मिल गया है. So what is the product that forms? C double bonded to OH, and that is H8. And these are basically my acids. So मजे की बात बताऊं, this is your vinegar. This is your vinegar, acetic acid, vinegar, जो आपकी ये आपके कार्बोक्सिलिक एसिड्स हैं. तो आपको पता होना चाहिए कि शराब से आपकी विनेगर बनती है. Let's do some examples of these. So let me draw this again. This was H, this was OH, and this was H. These two are going to be lost, and KMNO4 is going to give it an oxygen, so H2O forms. And what happens is that the KMNO4 gives this hydrogen and oxygen as well. So this oxygen is going to come here. The carbon bonds to the oxygen, which bonds to the hydrogen. And these two make a double bond. All right. Sir, nice seeing Shehzade here. Hello, sir. Oh, sir, Abbas aa gaye. Assalamu alaikum, sir. Okay. So basically, mehnat kar rahe hain sare. Okay. So basically, what happens is one oxygen is given right here and the other oxygen is given right here. So if I ask you to write the equation for it, which is never been tested, but is a part of your course, it might be tested this year, which I reckon. How many O's should I write here? How many O's does KMNO4 give it? How many O's does KMNO4 give?
एक
की दो की तीन. KMNO4 gives one O to the H2s and it gives one O right here. This is the new things that are formed. One O here. This was the double bond which formed. And this was the O that KMNO4 gives. So how many O's did KMNO4 give? It gave one O to this and one O to this. This has never been tested. So in total, 2 O's were given. That's the equation. You need to know this, never been tested. Never been tested, and it's in your course. Sir, can you make the document out of this so we can ratify it? It's unfortunate. So that's basically that, right? That is basically that. And this is basically my ethanoic acid. Ethanoic acid. What is ethanoic acid? These are carboxylic acid. That's the end of alcohols. Alcohols, you could have also used another. There is an observation that you need to make. Acidified potassium manganate is purple. And once it oxidizes the alcohol, it goes from purple to colorless. And the practical example for that is when these breathometers were not made in the foreign countries, in the US and in the UK and on all these places, what happened is this equation part of O-levels? Both O-levels and IGCSE, never been tested. This is the oxidation equation of alcohols. ठीक है. So basically what you need to understand is, later on I'll teach you. अभी तो मैं ऐसे तोड़ रहा हूँ to make sense for you guys. Later on I'll teach you a trick, yeah. But I'll teach you the easy way later on. But what's it called? What was I saying? The reason why this is such a practical use of these oxidizing agents के बाहर मुल्कों में होता ऐसे था. In the US, in the UK, when these breathometers and all of these things were not made, उनके पास ना एक गुब्बारा होता था. They used to have a balloon, and in that balloon they used to have acidified potassium manganate, right? Acidified aqueous potassium manganate. So जब उनके पास acidified potassium manganate होता, some cool boys and cool girls like you guys would be driving, Gucci and astaghfirullah, drinking and driving, never drink and drive, but drinking and driving. And then the police, the cops, they catch you and then they take you out of the car. Like, hey, you have the right to remain silent. This and you like, cop, sir, I haven't drunk anything. I'm not drunk. What are you saying? Then the cops tell you, hey, I have a balloon which has potassium, acidified aqueous potassium manganate. He tells you to blow inside that balloon. So, sir, never drink. Yes, please never drink. Astaghfirullah, halal, astaghfirullah, hal anta halal. Hal anta wa ana all halal. Jami'an halal. So basically, he tells you to blow in it. And if the color changes from purple to colorless, that means that your breath contained the alcohol vapors. So easily alcohols were oxidized into the carboxylic acid. That is the birth of carboxylic acids. जो आपका vinegar हो गया, बाकी सारे weak acids हैं, ऐसे आपके बने. तो experience लग रहा है सर भाई मैं ऐसे काम नहीं करता, अल्लाह माफ करे. But there is another oxidizing agent as well, which was previously in your course, but now is not in your course, which is potassium dichromate, acidified aqueous potassium dichromate. It gives the color of orange. It has the color of orange, but when it oxidizes alcohol, it goes from orange to green. सो ये पहले होता था, अब नहीं होता। तो हाँ, बलून में विनेगर ही बन जाता है, एब्सोल्युटली। पुराने जमाने में ऐसे होता था। अब तो भाई मशीनें आ गई हैं, अब तो आपको एग्जैक्ट बताते हैं कि दिस इज द सेफ पीएच, दिस इज नॉट द सेफ पीएच। सो दिस इज द एंड ऑफ अल्कोहल्स एंड द बर्थ ऑफ कार्बोक्सिलिक एसिड्स। सर सल्फर ऐड करते हैं? कोई सल्फर सुल्फर नहीं ऐड करते। कार्बोक्सिलिक एसिड्स एंड आई एम फ्लिप एंड टायर्ड। सर बस बस ट्रक। बहुत थक गया हूँ यार। I just very tired. बस यार, seriously I also think बस यार, बस हो गई। सर खत्म, ब्रेक के बस। भाई इतनी लंबी, मैं तो बड़ा हैरान होता हूँ टू ऑल दीज गुरुज दैट डू दीज लाइव मैराथन सेशंस। मेरे से तो नहीं होता भाईजान। मैं तो थक गया हूँ सीरियसली। बट ये जो हमने किया है, आपकी पहले चैप्टर्स में कोई क्वेश्चन होगा, सारे हो जाएंगे, राइट? Just wait till we finish organic chemistry. Hopefully we're going to take a class tomorrow. Do you want me to take a class tomorrow? Amar is saying, sir बहुत मजा आ रहा है, please continue. Sir please खत्म कर दें यार। नहीं हो पाएगा, मैं थक गया हूँ, अब मेरी एफिशिएंसी कम हो रही है। कल कर लेते हैं
Sir?
क्लास। जी मान। Let me just stop the recording. Wait. Before you guys ask questions, let me stop the recording so that आप लोगों की अच्छी प्यारी प्यारी आवाजें recordings में ना आए यार। Let me resume. Okay, so those of you who made it so far, we are going to continue with carboxylic acids, esterification and polymerization, homologous series, advanced naming, and isomerism in tomorrow's class because all of you guys are requesting it so much. So we're going to do that. Those of you who have certain queries, you guys can contact the coordinator, which keh raha hoon, who is Noor. Noor is the coordinator. I'll write the number right here, 7702015, right? Those of you who want to contact me, this is Miss Noor's number, right? तो आप इनको मैसेज कर सकते हैं to get the link of the discussion forum, which is a free forum for students who can discuss their paper queries and all of that stuff. ठीक है? If you want to contact me, please do not contact me for chit-chatting reasons. I don't have that much time, and only contact me for personal reasons, not for any chemistry questions. All the chemistry questions should be discussed in the discussion forum. If nobody is able to give answers for that, I will obviously give all the explanation there, right? So that's me, Sulaiman Khan. This video is going to be uploaded on YouTube at Carboxyl Chem. That's the handle, right? आजकल तो @carboxyl chem आप डालेंगे तो आपके पास ये वीडियो आ जाएगी, आज रात ही आएगी, right? Tomorrow let's have a class at 8:45 p.m. So again, we're going to start at 8:45 p.m. I'll share these notes in the discussion forum. So IGCSE discussion forum में मैं ये share करूँगा. Again, we're going to start tomorrow's class at 8:45 p.m. and hopefully finish off everything, including a worksheet, which is the worksheet of complete organic chemistry. And that is going to be more than enough for your final paper. ठीक है? So that's it, 8:45 p.m. What is the date tomorrow? I'm going to ask them to make a poster and upload it. So 26th April, please, those of you who missed this session, you guys can always watch it on YouTube. Don't be disheartened if you did not get the opportunity to join the class live. Yeah, it's fine. ठीक है? तो YouTube पे एक दफा do watch this entire video once in multiplied by 2 form in the morning because your efficiency goes down, right? So it's 26th April 2024, 8:45 p.m. PST and 8:45 p.m. to 1 a.m. Any questions whatsoever? Let me stop the recording and now I'll take your questions. पूछे जी, सवाल पूछिएगा अब।